talks. So we welcome you to be a part of our knowledge, drive. This is students and faculty and all the people who have registered are gaining from this symposium. Very informative talks. We welcome you to that.
Thank you. Thank you. We are happy to share, and I'm glad to share with our students who's our future pillar. And there are some very excellent topics. Yesterday was on the Atal Tunnel and all that. It was very good. Yeah. Thank you for the organizing.
And, yes, all credit to Professor Rani, who has been spending a lot of time on this and organizing it so well.
Sure.
And the team of students.
I think she has been on it. Yeah, I think she keeps her WhatsApp and the email ticking all the time.
Thank you, sir.
She works very hard.
Thank you so much, sir. Thank you, sir. We are honored that the IGS president from Singapore joined for today's session. That's what is the main focus. And now we are just we'll wait
the
for
immediate past president, 2018.
Yes. Still, we have the persons from Singapore to support us. That's a main important thing. And thanks to Srikanth also for bringing you in to connect with us.
Happy to share with students. Yeah.
Yes, sir. I will wait for Anil sir also. He'll just join him. He'll just join.
Well done.
The IGS has been very active in the college. Even prior to the symposium, we had a series of 6 or 7 webinars which were focusing on different areas. And other chapters in the college are also very active. We have Institution of Engineers Students chapter, then the Civil Engineering Association, then Bhumitra Sena Club, which is devoted to nature. So we had a lot of webinars during this 2-3 months on varied topics. And it was very, very useful. And this symposium caps it all with a lot of international speakers and national level speakers. So I think everybody is benefiting from this.
Sure. I mean, the pandemic this year has changed the dynamics, isn't it? I mean, yes. There is some negative side, but there is a lot of positives to take out of this. Yes. I think, on the pandemic itself, I think we're all learning how to cope with this. But on the knowledge side, I think there's quite a lot of sharing that has never happened before.
Yeah, I think this webinar type of thing will stay with us even after the pandemic goes away. Definitely it will go away after a few months. But this way of communicating and sharing will remain with us. It is a plus point. So that is definitely there.
I think so. I think the immediate challenge for all the academicians and then those who are organizing is how we actually keep the students engaged while you are actually on an online platform. I mean, this is always a challenge.
Yes.
With some difficulties, you may actually be able to secure people who are ready to share. But we should have the right forum to make sure that the students who are, fully engaged, and they benefit out of this. Yeah, this is quite unprecedented, isn't it? The knowledge sharing.
Yes, I think if you look back maybe 6 months or so, maybe 1 year back, we never thought this way of holding seminars and things like that. Yeah. And we had even speakers from US, from Houston, places like that, which in normal times we will never think. We will never think, and it will never be possible. So students have gained immensely from this change in way we do things. So even after the pandemic goes away, this may remain with us.
I think so. I mean, even for me to listen to something like an Atal Tunnel would have taken me, it would have happened somewhere in the next 3 years. I would have still come across this iconic project, but this platform has made it easier, and then I could listen to this pretty quickly.
Yes.
So that this would have gone to an international paper or something, conference that you have to be registered and you have to be there to be listening.
Yes.
If it is in a paper, sometimes you can still miss it. But if you are in a conference, you are glued to it. If you are through 2 or 3 days, you are committed to it. It's only that way you can actually listen to a project like Atal. But this made it possible. Yeah. Thanks to all of you.
Yes, thank you. Thank you very much. I think all credit again, as I said, goes to the students chapter. Students have been very active in organizing, preparing brochures, ably mentored by Professor Rani and Professor Kannan.
Sure.
All credit goes to them. All credit goes to them. And also the IGS chapter for supporting
Sure.
the Trivandrum chapter. And
it gives a lot of credibility, and that makes it a lot easier for people to organize. Excellent.
Narayanan, sir.
yeah,
Hello.
tell me. Yeah.
Hello.
Yeah, we can hear you. We can hear you.
Yeah. I am AP Singh. I am calling from Delhi. And I am a EC member of IGS national body also this term. So from the very beginning, I am following this webinar and this program. And IGS, this is the first student chapter who is organizing this event in such a large way, and
Yes.
very effectively they are organizing the things. So an event organized by student chapter, it's tremendous, and they are doing a lot of. They have put a lot of efforts, and very high quality lectures or contents are deliberated in this course. So really a tremendous job done by the student chapter of that IGS.
So we are encouraged by
Thank
your
you.
comments. I think I'm sure students will scale larger heights based on the encouragement you have given us. It's definitely an encouragement for the students as well as mentors guiding them to do things in the appropriate manner. I think they have done a wonderful job. So,
Thank you, Singh sir. I hope that Dr. Anil Joseph sir also joined. Welcome, Anil Joseph sir and Chandran sir. Is Dr. Anil Joseph sir from IGS Kochi. He's the secretary of IGS Kochi.
Hello.
Yeah.
Actually.
Thank you for the invitation, sir.
Good afternoon.
Sir, welcome, sir. So I remember you giving lecture at Institution of Engineers Trivandrum on the Kochi merit flats. I don't know. I think we had some discussion also during that time. I'm very happy now that you have come to our college in virtual mode.
Santosh.
Sir, hope that we can move up. We can start, sir. Right?
Yes.
Hemna?
I think we'll keep the time, definitely.
Yes, sir.
Yes, ma'am.
Yes. Please start.
A very warm good evening to all present here. Welcome to the fourth day of Symposium on Highway Infrastructure and TSR Lecture. So today we have two sessions from 3 to 4 p.m. and 4 to 5 p.m. So the first session is handled by Engineer Chandrasegaran Sundararaju, PE, GEO, Singapore and Malaysia, PE Civil, Singapore, ACPE, MIEM on the topic Construction of New Bugis Station for Downtown Line Contract 903. The session is chaired by Dr. Anil Joseph and co-chaired by Steffi Mary Simon of first year MTech batch. Dr. Anil Joseph had done his graduation and post-graduation in civil engineering from NIT Surat. He was awarded PhD from NIT Calicut on his work on pre-compression of soft marine clays and from Open International University on his work on pre-stressing and hollow shell technology in earthquake-resistant construction. He is also the director of Geostructurals Private Limited, a leading foundation and structural consultancy firm based at Cochin. He is also the National Executive Committee member of IGS and representing India in International Technical Committee TC 220 on field monitoring in geomechanics. Dr. Anil Joseph is also the secretary of IGS Kochi chapter. So before moving on to the session, I would like to remind all the participants some general instructions. All participants are requested to mute the mic. Doubt clarification time will be provided at the end of the session. The feedback form is separate for 2 sessions. It will be provided at the end of each session in the chat box and also in the WhatsApp group. So now, I welcome Dr. Anil sir for giving the introduction of today's speaker. Welcome you, sir.
Yeah, good afternoon, everyone. It's a pleasure to and a great sense of privilege also for me to be the co-chairperson of this session, where in fact the Marine Engineering College, the IGS students chapter is doing a tremendous job, and it's from the Symposium on Highway Infrastructure and TSR Lecture organized from December 1 to 5, and lot of very much important technical contents are being shared. It's a great opportunity for the students and the engineering fraternity to interact with each other, and I congratulate the organizing team comprising of Dr. Rani, Principal Marine Engineering College, and the team of IGS Trivandrum chapter for taking the lead and organizing the event. Now today we have a great speaker, Engineer Chandrasegaran Sundararaju, the Regional Design Manager and the professional engineer in technical engineering in Singapore and Malaysia, and he is also leading an Asian Chartered Professional Engineer, ACPE. Dr. Sundararaju has got more than 30 years of design and construction experience in both major building developments as well as underground infrastructure in the region, having worked as both consulting engineer as well as specialist subcontractor. He has also served as the president of the Geotechnical Society of Singapore in 2018-19. Chandrasegaran is currently regional design manager with Bachi Solentech Singapore Pte Limited, covering the region that includes Singapore, Malaysia, Indonesia, and Australia. His major area of expertise in the deep excavation, deep foundation, and ground improvement in both building and infrastructure space. Chandrasegaran has also published few technical papers to share the knowledge with the industry colleague on deep excavation in large projects. Today, he will be sharing with us on a case study on the construction of a new Bugis station for downtown line contract 903. And I would like to also add that in my PhD work, in fact, I have referred a paper from this particular area in the paper in 1993 by Chu et al. In the construction of Bugis station, where they used chemical line pile for the stabilization, and 1.2 meter thick diaphragm walls were constructed, and 7-stage strutting was used, and ground improvement was done by chemical line piles. So we have also done a bit of ground improvement study, and this paper was referred in my PhD work. So it's a great opportunity to hear from the man who has done the second stage of work for the Bugis station, and let us be all ears for this. Welcome, sir, for this program.
Thank you, sir. Now I invite Engineer Chandrasegaran sir for the session. Over to you, sir.
Good afternoon, everyone. Thank you, Dr. Anil, Secretary of IGS Kochi, for the very warm welcome and very generous introduction. Really appreciate it. Thank you very much. And I would like to thank Marine Engineering College for the invitation, and Professor Rani, the head of the department, Professor Narayanan, and most importantly, the IGS student chapter, who has been very active and doing a great work in spreading geotechnical knowledge to the student community. And also like to thank TC202 for the co-sponsoring of the event. So I would like to, with that, I get started. There's two different things in the world. One is geotechnical engineering. And we are in good hands thanks to all the esteemed professors that we have, IGS, good work, and so on. Two is listening to a geotechnical engineering, especially when India is batting. So I think there's a cricket match on, and I hope all the students are able to glue themselves to a seminar and listen to the next 2 hours. So with that short note, I would like to get started. I would like to share my screen. I hope I get it right. Okay. Could you all see my screen?
Yes, sir.
Yes, sir. Yes, sir.
Right. Okay. So with that, I'll get started. I'm going to do this in 2 parts. Yes, I can. Right. I'm not able to get my screen down to my. Can you all see the screen? Okay, so I will just get started. Just a bit of introduction to geotechnical engineers. It's a definition of geotechnical engineering. We all know it. That's why we are here. The branch of civil engineering. Geotech engineering is a practice that relates to the engineering behavior of earth, soil and rock and its material. It's involved in all the construction activities taking place on surface or within the ground, from a design of simple residential house to an MRT construction, a metro construction, a deep tunnel construction to reclamation and earthquake. So we are responsible for evaluating the soil conditions and its engineering behavior for subsurface and above surface soil formations and design safe and efficient foundation and other engineering solutions. So just a bit of a small intro. That's the famous Pisa Tower. That's the engineer who did this work many centuries ago. And that actually is the design intent. And this is exactly what we got. And of course, somebody can say if they never did this, you won't have large amount of tourists coming to this place. But the question is, who is going to solve this leaning Tower of Pisa? Could this be one of them? Who is going to straighten it? It could be any one of us who are listening to this lecture, one of you who is the future geotechnical engineer who is probably going to find a solution to this. With that small introduction, I just want to get started with the geotechnical engineering. What are the possibilities as an engineer? Could we be part of the transformation? I just want to share a picture of Singapore. This is a picture of Singapore taken from the southern side of the island. Whatever you see, the green patch or the white patch on the left and right hand side, this used to be a sea. This is actually in the photo taken in the 80s. This used to be a sea, and there's a reclamation done. Everything from this used to be the shoreline. Everything to the south of this is actually reclamation. Now, what exactly they were planning to do? Some of the iconic landmarks that you see today, they're all there now. And this was made possible first in the reclamation and all these famous buildings. So you can see the Marina Bay Sands, you can see the barrage, you can see the new station under construction where I am involved. There's a new memorial that's coming up. These are the two rivers and they are separated from the sea. And this structure was built in one of the softest marine sediments you would ever come across in life. All this is made possible and it still looks like a garden. Now, all this is made possible by geotechnical engineers. So the opportunities are limitless. This is another view taken from the land side towards the sea. You can see the barrage is nearly complete, and you can see the two rivers are joining into the sea. The reason why the barrage is built is to actually store all the soft water, the rainwater that comes from the city, gets collected here. They get pumped, treated, and supplied back to the Singapore population. This is just to secure water. And you can see this construction. This is actually the construction of the Marina Bay Sands, the popular iconic building. And I'm happy to say that that was completed. The Gardens by the Bay is at the back. I'll show you a photograph when it was completed. This is actually the Marina Bay Sands, and this is the Arts and Museum Center. The Gardens by the Bay is at the back, and a lot of other works going on. And I'm glad to share that I was involved with this. There are a lot of projects at the back I was involved as well, and I'm here to share one of the projects from here. Okay, so today's presentation I will split into three parts. One is just a small intro about the company that I work, and I want to talk about the downtown line new Bugis station. But before I do that, I want to explain a little bit of different method of construction. This is the company I work for. The company I work for is actually Soliton Bashi, which is here. But it's part of a very large Vinci construction group, and there are many companies under them. We belong to the specialties division, and under this division we have 6 companies rather. There's one more company, and with a turnover of almost $3 billion. And I'm actually somewhere here. I work for this company, Soliton Bashi. This is actually the soil part of the specialist companies, and this is the structural part, and this is the nuclear part. What exactly exactly we do. We do engineering works interacting with ground. Any work that's interacting with ground. It can be underground car parks, tunnels and metros, port construction, storage tanks, environmental protection, or special engineering works like urban excavation. In the middle of a city, we need to make a basement. We do that. We do a lot of dams. In India, we have done TSR Dam. We have done Shubhan Street Dam in the last 10 years. And then foundation for the buildings or civil engineering works. We do a lot of foundation. We do slope stabilization. We do structural refurbishment as well and underpinning. So this is actually, the team is important. There is almost more than 10,000 people work. But what we bring to the field is actually the people. We come up with design solutions, very innovative. And there's a very strong plant and fleet, the equipment that we use to construct those. And then our commitment to sustainable development. Talking about geotechnical, the future is all about sustainable technology, and we need to keep an eye on this as well. So where are we? We are present all over the world, more than 100 countries. We are well established in 40 countries. In Asia alone, we have about, we do about close to 400 million euro turnover. The company employs more than 10,000 people, and we have been in Asia from 1938 onwards. So what are the expertise we have? We do a lot of cutoff projects. As I said, we do a lot of dam cutoff projects. We do a lot of building and basement works, diaphragm walls and deep foundation, rail and road infrastructure works as both as main contractor and specialist subcontractor. There is just some list of projects that we have done. This is the area that I was showing earlier, Marina Bay, more than 30 odd buildings that we have done here, the basement, foundation and so on. This is the famous Marina Bay Sands. I was involved with the basement as well as the tower foundation. This KLCC, Petronas Twin Tower in Kuala Lumpur, I was not part of this company yet because this was 25 years ago, but I was actually working with a consultant who was involved with this foundation design. So I was part of the design team developing this, and I was instrument in analyzing the pile group and the raft analysis. And by the way, that's actually the deepest foundation in the world at 125 meters. It's not just the building, and we also do tunneling, and these are the tunnel boring machines we are using in Singapore. This is a job that was completed about 4 years ago. And we have been involved in Singapore for more than almost 26 LTA projects, Land Transport Authority. These are metro projects. Underground construction, as I said, we are involved in basement works, metro rail works, a lot of cut and cover tunnels, shaft for power cables and sewer lines, flood mitigation ponds and reservoirs. And with that small introduction, I would like to get into today's topic. But before I go there, I just want to explain, because the topic I'm going to talk about, there are 3 different methods of construction that was used. And the bottom-up construction method, top-down construction method. And I want to give a small introduction before I dive into the details. What exactly is a bottom-up construction? So you got diaphragm walls, which are retaining walls that are constructed on both sides. You can see here there is a diaphragm wall constructed here. There's a diaphragm wall constructed here. People are trying to make an underground metro station here. In order for you to excavate down, you need to have this wall, and you need to have struts that support this. You need to have king posts that actually reduces the span, and then you need to have the wailers. Once you've got all that, then you go down. So the bottom-up construction is you use the steel struts to go down. Once you reach the bottom, you pour your slab and you start making the slabs on your way up, on your way bottom up. When you're coming up, you start to remove these temporary props, these steel struts. And once you have removed it, you got the permanent box in place and your structure is complete. So fairly simple and straightforward. What is good about bottom-up construction is this is open to the sky construction. It makes it a lot more easier for a crane that's sitting here to drop the material to install the struts. Or if you want to pour the slab, you have to put the rebar. You can actually send this through the gaps, and then you can pour your slab with the concrete truck here. And then when you're removing it, it's easy to use a crane and remove it. Everything is open to sky. I will say why this is important. The next type of construction is you can actually use anchors to do that. When you use anchors, this was the ground, this is the wall you have just installed. You excavate, you install an anchor, you reach the final depth, you make your slabs, and then you go up. Pretty straightforward. This is even better than the strutted excavation because this is completely open to sky. It's a lot more easier to muck out the earth from here. And then when you come up, you remove de-stress the anchor, and then come all the way to the top and complete the structure. Just want to show you one job that we did in Hong Kong. This you can see is almost 25, 30 meters deep. You can have 7, 8, 10 levels of anchors. There are so many levels of anchors, no issues. You install the anchors as you go down. You can see this is a completely open to sky excavation. It makes it a lot more easier to excavate. When you have done that, you make your slabs and then you complete the job. So the next one is actually a top-down method. You can see here, this is actually the walls that are actually supporting the basement. These slabs are there in permanent. Now, some clever guy comes up and says that if I'm going to have this slab, why do I have to spend money on the bottom-up construction where I have to spend some money on the steel struts and anchors? I save the money, why not try to use this? So they started thinking how to do it. But of course, when you make the slab, it is not easy to, because you have to make this slab and go down and make the next slab. Use this actually as a support in temporary stage and go to the bottom. But what makes it difficult is once you cast this slab, it makes it more difficult to cast this slab. You have to leave enough gaps for it to drop all your material. You have to muck out. But if you manage this correctly, there is a very good chance that you actually save the money that you spend on temporary props. But you also can actually, if you're having a tower in the middle, while you're going down, you also can take the opportunity to start to go up. You can actually let the tower start to go up while you're still going down. So there is a time saving. You spend a little bit more money, but it's got some good benefits here. So these are the fancy top-down construction that you can see here. You can see this whole thing is one big development, but there are so many openings because the earth has to actually come out. They have to pour the slab, the rebars has to go down and so on. They keep so many openings to make it very efficient. But of course, these slabs cannot be constructed without all these plunge columns. You can see all the steel columns supporting these slabs. So the next one is actually a circular cellular structure. You can see here there is no struts, there is no anchors, there is no top-down construction. All you need to make is a wall which is circular in section. You use the hoop, the engineering principles. They work in hoop. As long as the concrete can take compression, which is what it's supposed to do, you can use that to excavate down. This is the foundation that's installed. You reach the bottom, you pour your slab and start to come up, and that's it, it's done. So this is very efficient, very quick, but you need to design this. Once you learn how to do a single circle, you can actually do double, you can combine them. It's quite limitless. This is a design that I did in Singapore, first time in Singapore. You can see I don't even have the wall in the middle, there's a wall below. But these are the different shapes that you can do. And once you have done this, there is someone who has done with 6 or 7 circular cellular structure. And you can even imagine to do an ellipse. So with that small introduction, this is actually the basement we did for the Marina Bay Sands. This looks like one big circle. In fact, this is a peanut. This is one circle here with a cross wall in the middle. You can imagine how open to sky. It's very easy to drop the material, pour the slab, and reach the bottom. This makes it very, very easier and very, very efficient system. So with that small introduction, I enter into the small topic, and I'm going to spend next 45 minutes explaining this. This is a very complex project, and I hope you can follow. And if you have any questions, please ask the question, and I'm happy to share what we have done here. So the new infrastructure in mature and urban environment. So, the new projects that we do in Singapore, Malaysia, or in Delhi or Chennai, Kolkata, or in Kochi, they are no longer done next to a green field. There is already existing buildings. There are people living there. So there are things that you need to take care. With all these constraints in mind, you should still come up with a safe way of constructing all this. So you need to come up with some innovative solutions to resolve the problem that the expansion of underground infrastructure brings. You can always put above ground. Once you do that, there are a lot of constraints. If you want to make a road underneath or you want to have a facility crossing, that's not easy. But if it is underground, you can do a lot of things on surface. But of course, you need to make sure that the underground structure doesn't move in future. So in Kuala Lumpur, Singapore, Hong Kong has done quite a lot of work. Kuala Lumpur has actually done the first phase. Second phase is under construction. Third is being planned. Ho Chi Minh City in Vietnam, there's done 2 lines under construction. One is already in operation. And in India, of course, this is one of those places you want to be. if you want to be in underground construction in metro. Delhi, Mumbai, Chennai, Bangalore, Kochi, Kolkata have operational metros, and many cities, Pune, Hyderabad, everything is a lot of under construction or either under planning. So if you really want to be in this, next 20 years in India is a place to be. So in this presentation, we are going to look at a new Bugis station. I will go into the details shortly. This Bugis station is actually in a very congested environment, and how we manage this to construct is what I want to show. So before that, I just want to give a small intro to the Singapore MRT system. This is a system map in 2020. I won't go into the details, but you can see the different colors. There are east-west lines that runs from the west to the east, so Changi Airport, and there are north-south lines, there are north-east lines, there are circle lines, and this is what you have at the moment. There's a downtown line, which is the blue line, and you can see here it just circles around and goes to Changi again, Changi Airport. But by 2030, you can see that this map will start to look like what you see in Tokyo or in Paris or London or New York. So this is supposed to cross 400 kilometers by 2030. And there is a cross-island line which is under construction, which I'm tendering at the moment. So there is huge amount of work that's being planned in the next 10 to 12 years. So these are the future lines. I just want to give you some line names for it. Tuas Extension, Jurong Line, which is under construction. Thomson East Coast Line should open completely in the next 2 years. Cross-Island Line, eastern side is being tendered, western side is being just designed. Northeast Line, which is already being extended. The downtown line, which is in operation. There's a lot of things that are under construction in Singapore. So now with the network of 122 MRT stations, this is what Singapore has, and 40 LRT stations across the island and more to come. The railway network is one of the most popular modes of transport in Singapore. The whole idea is actually to make sure that nobody walks more than 10 minutes to reach an MRT. This is actually what is the government's target. And with that in mind, they are coming up with so many lines: the Cross Island Line, Jurong Line, Circle Line, Northeast Line, and Downtown Line. So by the time when we reach 2030, we'll be at 360 kilometers. That's the goal, and I think we will get there. The future, this is what is being planned or being constructed: Thomson East Coast Line, Thomson Line, Circle Line, Jurong Line, Cross Island Line. So the project, so the detail, this is actually the map again. I just wanted to show where we are. So the project that we are going to talk about is Bugis, the blue line. The blue line that is going below the green line. That's actually the main challenge. This line is to be constructed underneath an existing green line, which is the east-west line. So just some intro. The client is the Land Transport Authority. The designer is Arab and is supervised by a joint which is called Golders now. It was completed, is in operation from 2013 onwards. And we had the station basic structure was completed in 2011, and for the system-wide contractor, the rail contractors to come in the next 2 years to finish it. We got the job in 2008, so it took us 5 years to commence operation. So it only took us 5 years to complete the station and be operational. Soliton Bashi is the company that I work for. We are in JV with another company called Co Brothers. This contract is worth almost $600 million, which is roughly 3,000 crores. So just some introduction. I don't have to go into the details. There's a lot of diaphragm walls, grouting works, mining works, and a lot of civil works. It's a huge contract here. So exactly what are the constraints we have? What is this area? So this is what we want to construct. That's the station we want to construct. It is next to a hospital. Once you have a hospital, this is a sensitive area. You need to make sure that your vibration is controlled, your noise is controlled, the dust is controlled. There's a lot of controls in place. And this is actually an office. Okay, this gives you a bit more flexibility, but you still need to make sure that in terms of engineering, you don't create any settlement next to the building while you're making this station. This is actually a shopping area. What it means is there will be a lot of people who will be crossing the road in the daytime or in the evening. And when they are doing that, they are stopping your work. So you need to manage that as well, on top of the traffic that you have. And this is actually one section of the area where there is old shop lots which are 80-year-old. You need to preserve them. There are people living there. which means you can't work in the nights. So this makes it a lot more challenging. And you have public housing, which is almost about 600-800 families living there. I will show you some photographs later, which means your noise has to be controlled, your dust has to be controlled, and you probably can't work in the nights and so on. And there is a sensitive 80-year-old row of shop lots. I will show this later. That needs to be protected. And there's an office where a lot of famous engineering offices are there. Okay, and with that, there is an existing station which runs east-west. And what we want to do is actually to make this yellow line underneath this existing station. So we will see the challenges in the next few slides. Okay, so just some introduction. There's a couple of pictures just to show. This is actually the main road. Under that, we are trying to make the new underground station. This is the east-west line. There's the existing station. This is the shopping area. This is the hospital. This is the sensitive old shop lot that I talked about because this is sitting on mixed foundation. And this is actually the public housing that I was talking about. I will explain a little bit more in detail. This is when the work is in progress. You can see exactly this road from another angle. You can see we have already started work. We have a building that's being demolished. I'll show in another photograph. And the traffic swings on both sides. And you can see here, this is the row of shop lot that needs to be protected, people living here. So we need to have sound barriers here while you're working. This hotel that was existing, the first thing we did on the site was actually to demolish this hotel because you need to have the station coming here. But of course, when you demolish this building, this is sitting on foundation. When I'm installing the new diaphragm walls, they will go through these piles. I need to take care of that. And the traffic is here. In the photographs that are coming further down, you can see this road is swung to here, swing to this side to make the construction possible here. One of the things I just wanted to highlight is you see the trees here. These trees were there 15 years ago and the trees are still there. We are not allowed to chop even a single tree. There is a tree here. We chopped one of the branches accidentally because one of the cranes fell down. And there's a fine of $15,000. That's roughly 8 lakhs that was imposed. That's actually the sort of imposition by the government, and that's the reason why they are being called a garden city. They try to maintain the greenery while you're actually building so many buildings around this. So this is actually the engineering part of the presentation. This is the station we are trying to construct. You can see the station is constructed in few parts. This is actually the layout. Now this layout is actually, you can sense this station is not a small one. It's 600 meters long. That's huge. Normally, typically they are between 200 to 250 meters, but this is very long because it had few junctions to cross. You can see here there's a main road. There's a main road. There are 4 major arteries. This is a main road going into the city. 2 here, 3 here, 4 here. So all this. And then you have a main road. This road is coming from Changi Airport. This is an expressway. There's a huge amount of traffic here. You can't afford to just start digging here. You can swing the traffic here, but you can't swing the traffic here because they're running in 2 directions. It makes it really challenging. And of course, this is the existing Bugis station, and we have to get underneath this here. Okay, so I just want to show you the elevation. So this elevation you can see is about 27 meters from ground. You can see on the left-hand side, there is actually a cut and cover tunnel where we need to get underneath. You need to maintain this. You need to cross. There's a crossover here. The train lines will cross over here. And then you have 2 shafts, and you use that to do a mining activity here. Okay, hang on. So, and then this is actually the station. Of course, you have the entrances you need to build. This is the existing station, so you need to mine underneath. This is actually another interchange here and here. So you need to mine underneath using some shafts. So you can see this is the existing station. You see here from ground you are excavating down, but here you can't do that because the trains are running here. So you need to mine underneath, and I will show you some details later. This is some soft, this is the soil conditions. Anything that looks in pink is actually the strong material. Anything in blue is actually the soft material. That's the Singapore famous marine clay. And the one in yellow is actually loose fluvial sand. And these generally, when you excavate through this, you lose water. Once you lose water, the effective stretch changes, there's settlement, and there's a big problem. So this is the yellow one is quite important. And of course, the soft marine clay is super important. Now, how this was done? This was done using diaphragm walls. You can see the station perimeters using diaphragm walls, and we use Barrett's as foundation. These are rectangular foundation, like both piles, but these are rectangular in shape. You can see the cross walls which are running between the diaphragm walls to beef up the robustness, and this makes the system very strong and reduces the deflection and thus the settlement. And these are the design parameters. In Singapore, these design parameters are defined by the engineers. So these are control documents. These parameters, if you need to change it, you need to spend quite a bit of time to convince the client. So the bottom-up section, that's the reason why I gave an introduction at the beginning. So this was done, you can see here, this part was done in top-down, this is in mine, this is in bottom-up. The station was done in bottom-up, cut and cover done in top-down. This is a mine section, another top-down, and then you have another top-down and mine section. That's the reason why I gave a small introduction on what this bottom-up construction and top-down and all that. So here, just show you the sections where we are actually doing them in bottom-up. So what exactly is bottom-up? So you need to have two diaphragm walls on both sides. You just keep an eye on this. This is the diverted Rocha Road, meaning the traffic is running here. I will explain with some photographs later. So the traffic is diverted, so you can actually mobilize your equipments to start making the diaphragm walls. What you want to do is to do the jet grouting. So you make the diaphragm wall, you make the jet grouting. And then in the next stage, you finish the diaphragm wall on the other side. You actually drive sheet piles on both sides, which I will explain why I do that later. Once you have done this, you can start excavating. And the traffic is still running outside because you start to excavate here. Because this is an open to sky excavation, which means the traffic can never come back to here until you finish this. Bottom up means you put the struts, go down all the way, and then you come up and then remove the struts. Until then, you can't have the traffic running here. This is what has happened here. So you can see here the people have gone down with a few number of struts and they reach the bottom and then they pour the slab. You can see here you have reached the bottom, they are making the slab. Once you made the slab, you start to come up, you put in the other slabs, and then you actually have to backfill this to put the traffic back, and because of that you need the sheet piles on both sides. Once you have done that, you backfilled, you reinstate the traffic back on this. Now the station is completed. So you use all the struts to go down, and then you pour the slab. As you come up, you remove the struts, and then finally you pour your roof slab and you backfill on top. Once you have done that, you actually start to backfill this as well, reinstate and pull the sheet piles out, and then you open the traffic again. So this is just some photographs just to show you how this is done. You can see this road still remains straight, but there are diaphragm walls being installed on the left-hand side and right-hand side. When you are making diaphragm wall, obviously you need to have the steel cages. They are being supplied, they are assembled and so on. And you actually have the slurry ponds that are actually used to support this trenching. And you can see in the next photograph, we have excavated. The big difference between these two is the traffic is running here. In the next photo, you can see the traffic is running here because we have started excavating. This is actually the bottom-up section. This is one of the entrances. You can see here when you are doing this traffic will be staying there for quite a while. But while this traffic is here, you can see that somebody is preparing a road diversion here to swing the traffic to here because there is some work to be done here. That is the sort of challenges that you have in an urban excavation. This is a very built environment where you have a lot of traffic that you need to manage. You have people crossing the road. You need to manage all this, and you have to swing the traffic here and there. There are jobs where you have to do almost 20 stages of traffic diversion. There's another view of this. This is actually coming from the city. You can see there is a mining work going on here. There is mining work going on there. And then there is further down, there's two more mining areas. So these are actually the struts that are used to go down. You can see the sound barriers which are here. So this is into the construction itself. You can see these are soft marine clay. I think Cochin has a lot of marine sediments. So these are very soft material. And the struts are installed, and I think we installed 9 struts on the way down. One of the biggest challenges you have when you are working in the city is utilities like this. You can't actually snap these utilities and push it away because some of the authorities don't give you the permission to do that. You need to support this. while you're working on both sides. You're going to excavate 27 meters below, but you need to have this utility supported or right until the end. So this is one of the biggest challenges. Although there was an advance contract, there are some utilities cannot be diverted, and we had to take care of it. And this is one of the biggest challenges. So now, as I said, the traffic was being swung here because there is quite a bit of work to be done here. You remember the traffic was running here? So now, you see here the work is, quite a bit of work is completed. You're seeing the traffic here, then we start excavating down to go down. And the important thing is the trees are still maintained. You can't chop the trees. If you chop the trees, you can lose the license, you can get kicked out of the project. Right, so now here we have excavated. You can see here we are about to pour the platform, under platform slab. But you can see the series of struts that are there. These are the diaphragm that we make. And these are the struts that you have. There's a lot of cross walls here that supports both the diaphragm wall from moving in and reduces settlement outside. And you can see the number of struts. There are 9 numbers of them from top to bottom. And you can see that people are dropping the material through the gaps. So there's a lot of engineering planning that goes behind this. Now this is nearly done. This, I think, is one of the openings for the extracted fans through the slab. This you can see is nearly completed. The diaphragm wall on the right hand side and the slabs are completed. And when the work is completed, you can see the hole is gone. They have already completed the roof slab. They are doing the last backfilling. And the last struts are there. So they're coming from there to here. The struts are being removed once they finish the backfilling. Once that's done, you actually put the traffic back and you straighten the road. And the work is completed. Of course, you need to. The next, you hand over the station to the system-wide contractor to come up with the rails. This is the completed station with the bottom-up section. So next is the top-down section. There are areas where you couldn't actually do bottom-up construction. Because there is a place where you need to maintain the traffic on top and you do a bottom-up construction. That means it's a cut and cover tunnel. You go down, you make a roof slab, you backfill, you put the traffic back and you start mining underneath. This is actually the top-down construction. There are areas that you just couldn't do bottom-up construction, and that's where the top-down construction was done. You can see here there is no room. There's actually a shopping mall here. There is actually a community center and a car park. You can't divert the traffic here. They have no choice. You can't close the lanes because if you had 5 lanes before, you still need to maintain 5 lanes during construction. So you have no choice but to do a top-down construction. So you make 2 walls, you excavate a bit, you pour your slab, you backfill, you put the traffic back, and once this is done, you can actually start mining underneath here. So you need to excavate below, casting the slab as you go down. How you do this in top down? So first you do one side of the wall and then you do the other side of the wall with a sheet pile installed. You can see that you cannot pour the slab because in order for you to pour the slab, you have to close the traffic. This is not possible because there is a building on the left, there is a car park on the right. You can't do that, so they put the traffic here and then they go down, they make the roof slab. Once this is done, you actually have to come and make a small retaining wall inside to backfill on this side. Once this is done, you can reinstate the traffic. You can see here you have not excavated here, but the traffic is back. But with this decking in place, you can continue excavating. So now you see the traffic is running on top, but because the decking is there, the roof slab is there, you start excavating, you make the next slab, you excavate, make the next slab, you go down, you make the platform slab and the platform. So this is where the trains will be running. And once you have finished it, nobody knows that you're actually making a 27-meter deep excavation underneath. The traffic is running like it has been before. So, and this is completely reinstated when the work is completed. Yeah. So this is the top down, and there is another section that I wanted to show. This is the narrow section. This, I think, is the portion is the tunnel after leaving the detail station, and just after the east-west line, you can see the section is very narrow. The Bugis village is on the left-hand side. It's exactly the same. You install the 2 walls with the diverted traffic. Once this is done, you go down and make a traffic deck and then your roof slab. When this is done, you reinstate the traffic. And once this is done, you go ahead and finish. You go down, make the next slab, excavate, next slab, all the way down, and you have trains running here. So that's the way this top-down is done. So I just wanted to show you some pictures. This is actually a portion where the top-down construction was done. It's actually somewhere around this width. They managed to cut into part of one of the car parks, so they managed to maintain the number of lanes. Eventually, the traffic has to come here. Now you can see here we are working here next to this building. You may think that this is a very cheap building, but it's actually 80-year-old sitting on mixed foundation. This can settle even for a slightest movement. We are working so close to the structure. The business is in an operation, and you can see the machines which are working 1 to 2 meters away from the building. We are installing some sensitive diaphragm walls here. And once this is complete, we actually reinstate the traffic and we mine underneath here. That's the point of this whole thing. I wanted to show you another view of the same thing. You can see that same building. You can even see that it's tilted. This is 80-year-old. People have worked over the years and it actually has become like that. So it's very sensitive. You have to take care of this. And you can see here, there's a view. We are actually dropping a diaphragm wall cage, and you can see the public housing at the back. There is about 5 or 6 blocks. They are demolished now, but there used to be 500 to 600 families living here. Any small noise, people will complain from there. We have to be very careful. So the machines, you can't just simply use any machine. So we have actually come up with some lot of innovations. We have to actually cover them up, and we actually have to make sure that they don't overheat. We need to provide the ventilation. Of course, the guy who's working from inside, we have to provide an air-conditioned cabin. And these machines, some of the silent machine that you can find. So this is another view from the public housing. You can see that the traffic is being diverted. This is actually bottom-up construction is going on. And this is where the top-down was done. And they reinstated the traffic, but they are working on this side because there's a mining work going on underneath. This is the existing station. And there is a mining work going on here, but you still need to maintain this road. This is the reason why you cannot just simply dig a hole and finish this work. You need to maintain the traffic. That's the reason why you have to make a shaft on this side, and you mine underneath it. I'll show you some of the details, how the mining is done. You see, this is actually the shaft where I'm going to mine underneath. I have a shaft on the other side where I'm actually driving my pipes and mining. This side I'm mucking out. But when I'm mucking out, I'm using the telescopic excavator. But of course, it's noisy. These people will complain that we did almost 35 years ago, 1985. And I think Dr. Anil said he referred that paper in his 1992 PhD thesis. So the chemical grout piles were done. The diaphragm walls were done by us. So I will just show you some of the details. This is just a 3D view of the mining. The mining is actually done underneath the existing station, under the Queen Street, under the Beach Road. These are the 3 areas the mining is done. So what is mining? So what you need to normally do is to make a shaft on both sides, install these pipes horizontally in the side, the top and bottom. Once you have done it, the soil is secured inside. You start excavating inside this section. You excavate 1 or 2 meters. Of course, the soil will start to collapse. So you need to start making these frames. You make these frames with these columns, the girders. Once these are done, you advance another 1 or 2 meters and you put the next piece of girder. And then you excavate further. So you keep on moving further using all these equipments. And then you keep on putting these girders and the frames in place, which support this roof and the pipes. And that stops the soil from settling down. If you have a live station running above, which is actually what we have, once these pipe roofs don't move down, the train operation is not affected. They can continue to be in operation. This is actually the principle of the mining that was done. So this is actually on the northern side. You can see here there is a shaft made on this side and this side to do the mining. These are just some of the busiest roads. You can see the shaft here, and there is also a shaft from this side, which is part of the cut and cover. And the mining is happening underneath this here. I will show you with a schematic sketch later. Once that mining is done, you get down. So that means you go down to the wall here. The wall here, you have to cut through the wall to make the rectangular box. That's exactly what this photo is doing. So the guy is actually cutting. So he's actually coring through horizontally. And then these blocks will be removed. Of course, there's soil behind which you can fall on your face. we need to take care of this. I will show you what we do to take care of this. So you can see how the pipes are being installed. These pipes are being installed like that. These are pneumatic hammers. These will ram through. So you will have pipes that are being injected with the ramming action. Once these are done, they are clutched, and they will actually form this kind of jointing. Of course, you are actually making ground improvement, and you have to ram these pipes through very hard, but that's the way this work was done. And of course, when you are driving these pipes, you can see here, they are doing these pipes. Once they reach the other side, they will start to go down and try to wrap up. Of course, we did only the 3 sides. We didn't have to do the one at the bottom. But when you are doing this, you can see they reach the other side. But these pipes installation is not easy because there is quite a lot of resistance when you are driving the pipes, because you're going through the soil or the ground blocks, and they are trying to come out. There is resistance from outside as well as inside. So we will actually have these the augers to screw through and remove the soil. Once you remove them, the resistance reduces and we can advance the pipes. It's not just this. So you can see here the pipes are all installed, and we are starting to put the first frames in place. These frames are you putting in, and you need to make sure that they touch this. So you need to close the gaps all the time, and you start to break. So you see there is a wall is still there. You need to break through the wall, but they are securing this first. Once they put the frame, they will start to go in, and this is what happens. You can see here the wall was not broken yet, but here they've not only broken the wall, they start putting the next frame, and you can see all the equipments, the excavators are working to remove the soil, and as you remove, you're putting more frames, and you reach the other end here. And of course, when you're doing all this, you are not allowed to have a settlement of more than 15 mm. And this is the key to the success of this project, because anything more than 15 mm, the train which is running on top, the operation can be affected. So you have to be very, very careful, because if you reach 15 mm, work suspension will come, and for next 4 months, they will completely stop your work. You need to actually first show why you caused the problem, whether it's because you made a mistake with the design or with construction. Then you have to come up with a remedial. You have to prove to all the authorities, and they have to be convinced. Then they allow you to put the remedial works in place, and then you start. You lose 4 to 6 months. This is a disaster. It's not just an independent station, because you can have 20 stations as part of the same line. The entire line can't operate because one of the station is not ready. And one of the station is everywhere is ready. One of the mining section, instead of 15 mm, it moved 18 mm, then it's a disaster. There's a delay of 6 months to 1 year. You can actually lose all your profit and even make huge losses. So you have to be very, very careful with this, not because of this, but you need to come up with a pure good engineering solution. And that's what has happened here. So you can see how they are being excavated. Why they don't look soft is because this is actually all ground improved, and they are almost like, sometime half a MPa to 1 MPa UCS. But there are places where there are some sand pockets, they even have up to 30 MPa UCS. So these are the road headers, and then the excavator that are removing the soil. And once you reach the bottom, you can see the pipes are still there, the frames are there, and they start to pour the slab. Okay, this is the juice of this entire presentation, which is the existing station, how we get underneath 80 meters. So this is the photograph. I think this is the project that Dr. Anil referred. This is an old station under construction in 1985. What we are trying to do, earlier you saw the green color building is this building. So we are trying to make a new line like this. This is the old station being made. This is 1985 to 1989. And then now we are trying to get underneath this. You can see even those days the traffic are swung to make this construction possible. Now what we are trying to do is this building that I was saying earlier, you can see that, can you see there is actually a small tilt here. This tilt is 1986. And if you go back to the photo that I showed earlier, I just want to show because this is interesting. You can see here there is a small tilt. It's exactly this building. That photo was taken from here. You can see there's a small kink. This kink was there. It's one of the disputes when came. We said that we have an old photograph that shows the kink was there even in 1986. Then the authorities believed this was not caused by us. So these are one of the biggest challenges when we are doing projects. So you can see from this old photograph, you see the kink is always there. So this is the building that we are trying to protect 30 years later. So the good thing about engineering works is you do a work 35 years ago, you come back and try to do another work underneath here. So sometimes this can be good, sometimes it can be bad, but I will show you an interesting aspect of this here. You can see there is a diaphragmal wall being made like that. This is where we are going to cut underneath later. This is actually, they needed this for the platform, but there is a use for this later. I will show you with some photographs. So this is the existing station. Now this is the south wing and north wing, and we need to actually make the mining underneath. This is 80 meters long. And then there is a paid link. The existing line and the new line, you need to actually let people cross without tapping out. So it's a paid link. And then we need to actually make the access through the northern side to make this mining, because if you just do it from one side, it will take forever. We do it from both sides. And then we need to make some mining underneath to make this paid link possible. And then we also need a shaft here to do the mining from here. So we created 4 axes in this just to do this 80-meter mining. So there is a temporary shaft made just for this. This is purpose built. And once this is done, we start to do the work. So this is the south wing to make the paid link. And this is actually the drive, the pipes that you start to drive underneath the existing station. And also you also drive from the northern side towards south. And then this is for the paid link. And then, of course, you are driving the long pipes here. And this is a part of the cut and cover closer to the Bugis village. So I'll show you with some pictures. You can see here on the northern side, Queen Street. This is actually the busy road that I showed. You need to maintain this. So this is part of the cut and cover. You make a new shaft to drive the pipes underneath the road to make the rectangular pipes, and then put the frames to excavate underneath while the traffic is running on both directions. This is a challenge. How this is done, of course, you need to actually make ground blocks. You have to do it from ground. You close one lane at a time and do your ground improvement blocks. Once this is done, you actually go down. We remove this this pipe at the bottom, but we replace it with a temporary slab. And you actually have to do some grouting all around. And once you have done this, of course, you need to do a lot of analysis. There's some improvement we did to the original design. And we have to prove to people that the movement is less than 15 mm and there is no damage to the adjacent building and so on. I hope I have another 5 minutes. I should finish quickly. These are some of the flat 3D analysis. This is a bit fancy because this was done 11 years ago. Nowadays, people do a lot of 3D analysis. 11 years ago, this, I think, was done in Hungary using one of the consultants from Singapore. And these are the structural elements modeled. These are the forces you get from every single steel set, the frames. Yeah. The bending moment is calculated for each and every one, and you actually design for it. And this is during installation. You can see here, this is actually, these pipes, when they are driven, they are supposed to go into the diaphragm wall. And of course, it's not easy to do it because as you try to go into the existing diaphragm wall, it will cause a lot of vibration for the train that's running on top. So we just pinned it. And then, of course, when you're driving these pipes, what I was saying is we did this 35 years ago. We find some of the king posts that are left in place, and we try to drive the pipes. This is actually on the way. So we have to send somebody through a 900 mm pipe. The guy goes in, cut the hedge piles that we provide, the king post that we installed 35 years ago. He cuts it. Once this is done, the pipe insulation is completed. And once the pipe insulation clutched and completed, we can actually start making the mining underneath. So here is the section that we are about to start. The pipes are in place. This is the top roof pipes. We need to excavate almost 10 meters below. This is actually the top roof, pipe roof. This is where the train is running. The existing train is running like this, east-west line. And this is the pipe that we have driven underneath that platform slab. And from here onwards, how we go about doing this is the train is running here. We actually punch through this diaphragm wall. This diaphragm wall was made by us 35 years ago. We actually stitch core this and remove them. And of course, when you remove the soil underneath, we have no idea because we have no soil investigation to know what sort of soil is this, because the existing station is there, so you cannot drill any investigation to find out what is the soil. So we need to discover as we go down. So we install ground improvement sideways. You can see here cement bags are there. You install them, and then you break the wall, make sure that the soil doesn't fall on your face. Once you have done that, you also have to put some nails. I'll show you. Okay, so here we have broken the wall through. You can see the marine clay. We don't know what is the conditions, but we have done the ground improvement horizontally from the shaft. Once this is done, we have to put a series of nails so that the nails will hold the soil from falling on your face. And then you remove them as you go. These rebars are actually GFRP rebars, which are easy to break. This is the glass fiber rebars. And you carry on like that. Now you can see here, this is the train. This is where the train is running. This is the platform slab. And this is the new beam that we have made. This diaphragm wall is, you see the shape. This is exactly what I showed in the old picture earlier. We are actually getting underneath this. Now, this is actually the top inward. So this is the top bench. And then I still have another 5-6 meters to go below. I will show you in the next photograph. You see the frames are there. Okay, so here this is much more clear. You can see this shape, this shape. This is the shape that we were doing many years ago. In the photo that I showed earlier, I don't know whether you can see. This is the old photo that I was trying to show. I think I lost it. Okay, so this is a photo. Can you see the shape here? This is the shape that we are actually mining 35 years later here. This is the place. So you can see here, this is exactly the same wall that we installed 35 years ago. So now this is the top bench. We made the frames for half of that. The invert is to be excavated. So you can actually see that the pipe roofs are already in place. The frames are in place, but the frames are not complete. They have to come all the way down. This oil is not removed. This is the bench. Once you remove them, you have completed the frames. The frames are already done. Once the frames are done, you start pouring the box, the slab and the side walls. And with that, you complete the work here. So this is how it is done. You can see the frames. And you can also see people are pouring the roof slab between the frames, and the concrete will be poured and you make the slab. And the train will start running underneath this here. And these frames, some of them will be cut and removed, some of them will be left in place. And the train that's running live is just above here. Now the work is completed. You can see that people can go from one to the other side at 80 meters. And this is actually the completed work. You can see here that this is actually the existing station. Here they are pouring the roof slab. Once this roof slab is done, you go down to the bottom. You know what is this? This is actually from the existing station. They will make some sumps and pits. This is actually is hanging from the existing platform slab or the concourse slab. So you can see all the structure is completely exposed. This is the old diaphragm wall. You can see we have cut it. This is the old rebar that we put in 35 years ago. We cut through this. And then people are pouring the roof slab for the new one, which is perpendicular to this. So with that, it's completed. I know this is not easy. This is a very complex project, and to explain in 45 minutes, not easy. And I hope I managed to do it. With that, I will complete my presentation. And if you have any question, I'm happy to answer them.
Thank you, sir, for the excellent presentation and very informative session. Now, the session is open for doubt clearing and feedbacks. Is there anyone from the participants having doubts or to share the feedback? You may use the chat box or you can unmute yourself. Is there anyone, participants?
Hello.
Hello, hi.
Sir, myself Ginsa, and I'm doing my first year MTech Geotech. So first of all, I wish to ask a doubt, and after that, I'll say feedback, sir.
Sure.
Sir, as you have gone around 27 meters down, you told that. So my doubt is what you did with that excavated soil.
Okay. Okay, this is a good one, especially in Singapore, because this is a controlled commodity. In Singapore, you can't simply dump it. You need a permit to dump in certain places. The government controls this. There are only 2 approved locations. You need permit to dump this. So we will have special earthwork contractors who will actually have the permit to dump. But before you start excavating, you need to apply to the government for permit, and then you dispose them. And of course, if your material is contaminated, let's say you're using bentonite slurry or you have any contaminated material, you need special permit and treatment before you can dispose them. And the other thing that we do nowadays is actually we take the soft material, mix them with some cement, and we turn that into a backfill material. You know, when you excavate a boat pile or a barrette or a diaphragm wall, you have some empty bore on top. You have to fill them. So we use back this material, mix with some cement, put them back here. These are the 2 things that we do in Singapore.
Okay, sir. Really, it was a very informative talk, sir. And it was amazing to hear the challenges that you have faced in this project and how you solved it. And also finishing such a big project without clearing a single vegetation. It was really mind-blowing. And also, it was very clear and concise sections, sir. You have packed a lot of information and shared with us. And I also find myself lucky to attend this informative and enjoyable talk. And also I take this opportunity to express my sincere appreciation and gratitude to you, sir. Thank you so much, sir.
Sure, welcome. Sure.
Yeah,
I'm fine. I'm glad it's useful.
I have a few words to say. It was really a wonderful presentation, a walkthrough for the last 35 years what was happening, and it's a great privilege for you to be part of the team before, and the same company doing after 35 years. A wonderful engineering principles have been put into application. So detailed that we studied the paying 3 principle, the bottom-up method, the top-down method, and the mining system was explained so deeply, and the problems which can be encountered was presented very well. Thank you very much, sir, for that excellent talk. We have a lot of questions, but then the time is the constraint. Sure. Because you have opened such a big sports area that there are so much of questions to ask, which we will keep in touch with you. But one single question I would like to ask: how do you manage the dewatering system when you are down so much of 27 meters below the ground level?
Okay, so this is actually a key, and it's a very important aspect. In Singapore, you are not allowed to drop the water table by more than a meter. This is the rule number 1. So once this is in place, you need to have a recharge wells at strategic locations. So you need to have an instrumentation plan and the recharge well system approved before you can start work. And you need to actually activate it before you start excavating. So which means you cannot start drilling when you have a problem. You need to have the recharge well systems on the side. So if you draw down water from the bottom, you need to put the water back so that you maintain the water table. You are not allowed to drop by more than 1 meter. You need to have an instrumentation that shows your pore pressure has not dropped by more than a meter. Because if you change by more than 1 meter, you change the effective stress that causes settlement. Because Singapore is the top layer in majority of the business area. The business district is actually soft clay, and of course it starts consolidating, and this is the problem. So this is what you are supposed to do. And of course, if you have accidentally has a problem, you have to start grouting them. This is really a remedial rather than a solution. But as a solution, you are supposed to have the recharge well system in place before you can start working. I hope it answers your question.
Yeah, since the soil varies horizontally and vertically and it's so difficult to predict, what was your experience? Whether everything has gone as per the planning, or was there any surprises when you did this job?
If everything has gone according to the plan, I have a very good chance of winning the US lottery. Yeah, so that's usually is the case. I have a much better chance of surviving standing in the middle of a highway, not hit by a lorry, than actually to predict the soil and getting it right. It's always a challenge, and this is where it makes it interesting for geotechnical engineers. For someone, I worked in Singapore and KL, Kuala Lumpur quite a lot. I thought I figured out what to do. Every now and then you run into trouble. And then suddenly I go and do a project in Sydney. I start from scratch, from zero. I have to have papers written by somebody like you to read about Sydney, understand, then only I can start my work. This is what makes a geotechnical engineer's life interesting. If I'm actually a structural engineer, with absolutely no disrespect to all the structural engineers, this is not repetitive work. You are discovering every day, and it's a challenge, but it is something that you will actually enjoy. And I think this is where I say, if you become a geotechnical engineer, sorry for the advertisement, but this makes it a lot more interesting for you to discover every day for the next 40 years of working life.
Thank you very much, sir.
Yeah, I can.
Hi, Professor.
Hello. Hi, Praveen from ARCADIS, Singapore. Yeah,
Hi,
I can.
hi,
Hi, Chandran. We met in ARCADIS office for CR 102.
Sure.
Yeah, so
Thanks,
I can corroborate with Chandran that regarding the geology in Singapore is very, very difficult to predict.
Yeah, for such a small country, it's a very complex geology. I think probably Praveen is going to talk about it shortly.
Yeah, I'm currently working on DTSS2 project.
Sure.
Yeah, T07 with Zublin.
That's right. Yeah.
So,
that's a complex project. I'm
yes.
glad you're going to present something to us shortly.
Yeah.
Hi, Chandran.
Hi.
Srikanth here.
Hi, Srikanth. I'm glad you could join.
Yeah, I could. I took the call on the way, but I didn't know that you and Praveen are going to gang up and go against the structural engineers.
Yeah,
I had no clue about it, but thank you for sharing your experience. Quite such a pleasure to hear you, and I hope the engineers in Trivandrum would get, motivated to listen to. Sorry, I was getting out of a cab.
Sure. Thanks to you and Professor Rani, we are able to share. Thank you.
All right. Good luck, Praveen, with your talk.
Yeah, thank you. Yeah.
Thank you, Srikanth and Praveen sir, for the joining us.
Hello. I would like to ask a question.
Sure. Hello.
Yeah, one moment. See, you were telling about for one thing, regarding structural engineer, I am specialized in structural engineering. But I was also thinking that geotechnical engineering is basically structural engineering below the ground line. Basically, you deal with structures which are constructed below the ground line. So it's a broad definition. So I think like that. Anyway, my question is, you said that during the construction of the station below, you had made cuttings on some of the diaphragm walls and things like that of the previous construction. My question is, where the drawings available of the constructions which were made in early 1980s, and what sort of analysis you had to do to ensure the safety?
Okay, this is always a huge challenge. Archiving and retrieval is not easy. Nowadays, the field of data mining makes it more interesting, and the next available technology, BIM, makes it more interesting. I think anybody who is working in the next 20, 30 years, they will find it a little bit more easier than what we do, the trouble that we have. We didn't have a great deal of complete picture. We did have, what went through, what was the wall that was done. We did the diaphragm wall, so of course we had to dig up this from our Paris office, because the Singapore office was closed for a couple of years and you lose all the data, but the Paris office had it. So the assessment of the structure built in 1985, 30 years ago, 40 years ago, there's also another project that we are doing at the moment. We have published, we have published one paper, another paper we are about to publish. This is where the experts like you come in to assess the integrity of the slabs as we excavate underneath, how much of deflection it can take, a structure that was built over the years, how the creep to be considered, something that was constructed with a lower grade of concrete, what is the E-value that we can use which impacts the deflection and so on. This is where we have to completely rely on experts like you to assess this for us. and you tell us that, look, I can't take more than 5 mm or 6 mm deflection, we go back and do a ground improvement that is consistent with your prediction and analysis, and we try to prove and we put the frames in place just to make sure that we don't deflect by so much. So first is the archiving. It's never easy. If it is not available, then we have to make some acceptable engineering assumptions. Second one is we have to rely on some very good structural engineers to make the assessment. I hope it answers Professor Narayan.
Yeah, definitely. Thank you.
Thank you. I think there's a question from a gentleman, E.G.
So we have a question in the chat box.
Sure. Okay, so let me...
With too much marine soil, and I did hear you saying that you improved the soil. I wanted to know, how did you go about that improvement? Can you please elaborate?
The improvement is done in two parts: vertical, which is relatively easy. When I say relatively easy, means if there is a utility that's running, and in Singapore or anywhere in the world, in most of the metros, you have all the utilities will always go through your project. That's your fate. So these utilities are there, so you can't install your ground improvement through these utilities. So maybe you can get it right 80% of the time. Then you start to do inclined grouting. We did this on this job because there were some utilities we just cannot drill vertically. You do it inclined grouting from the top. This is assuming you have access from the ground. There are places you just don't have this access. So the second one is the horizontal grouting. So you make a shaft on both sides, you get to the bottom, then you actually drill sideways or inclined drilling, and you start to ground improvement inside. And you have to have a technique that is compatible with sandy layer, loose sandy layer, or soft clay, and you need to improve it. Sometimes you may not be 100% correct. You may actually have a situation where sand is very easy to improve, right? Meaning that if you put some cement to it, it can actually go from SPT 10 to SPT 100 because it becomes like a rock. But in marine clay, it can improve maybe 3 or 4 times or 5 times. So you can, and then you can still have pockets that are not improved. So you need to still go with an assumption that the mass improvement that you have done is adequate. So you do it horizontally because you only have access to this after you get to the bottom. So for example, under the Bugis station, existing train that's running, I have to get to the bottom and then do the horizontal ground improvement as I move along. I can't even do the 80 meter in one shot. I probably can do about 15-20 meters, and then I start to move in. Then I stop my excavation. The guy come back to do a ground improvement for another 10 meters, and then I continue with my excavation and framing. So that's the way it's done here. It's a huge challenge.
Okay, thank you, sir. Is there anyone to share the feedback?
Sir, my name is Parvati Rajiv. I'm doing PG. It was a great session, sir. Mainly the method of constructions, the way the trees were preserved, everything was interesting. A great session, sir. Thank you, sir.
Thank you. Thank you. You're welcome. I'm glad you enjoyed it.
Anyone more? Okay, so I hope everyone is clear. So now, as a token of gratitude and love, we would like to present a virtual memento to Engineer Chandrasegaran, sir. Sir, can you please stop the presentation so that we can share the memento on the screen?
Sure. Thank you very much. Thank you for the opportunity. And I wish all of you to stay safe during these hard times and come out of this well. And hopefully everybody gets vaccinated soon and we can go back and practice our geotechnical engineering.
Yeah, thank you.
Thank you.
They say the vaccination may come in 2 weeks. That's the latest news.
I hope so. I hope so.
Yeah.
Thank you. Okay.
So this is presented to Engineer Chandrasegaran Sundararaju with deep appreciation for your visionary guidance and in grateful recognition for your enduring commitment throughout the symposium. We thank you for spending your valuable time with us. Thank you. Thank you, sir.
Thank you very much. And I wish you all good luck with the symposium and knowledge sharing and the knowledge gaining. Yeah. Thank you. Have a good evening. Cheers.
Thank you, sir. Now I invite the session co-chair, Steffi Mary Simon, to propose the vote of thanks.
Hello, am I audible?
Yes, yes.
In the midst of the cyclone warning and prevailing weather conditions, I thank Lord Almighty for enabling us to conduct the first session of this day. On behalf of Marine Engineering College, I take extreme opportunity to express vote of thanks to all who have directly and indirectly contributed in conducting this section. On this occasion, I express my profound gratitude and thanks to Mr. Chandrasegaran sir. Sir, we are really enlightened with your knowledge, and thank you, sir, for sharing such a beautiful, informative session with us. A special thanks to Dr. Narayan sir, HOD of Civil Department, and Session Chair Dr. Anil Joseph sir, and all the organizing committee, teaching and non-teaching staff for the inflecting support and coordination. Thank you all for joining this session.
Thank you, Steffi, for the very kind words. Yeah, thank you very much.
Thank you, Co-Chair.
Thank you, Steffi.
Thank you very much.
The feedback form of first session is shared in the chat box. All participants, please ensure that you fill the feedback form. Participants, please note that we'll have the virtual cultural program after the second session, Contact 2020, organized by talented students of Civil Department of Marine Engineering College, expecting all your support and encouragement. We will begin the second session shortly.
Thank you, Chandran sir, and thank you, Anil Joseph sir, for being with us. There were immense time you shared with us, and really thank you to spend with us. And again, we'll hopefully meet in another program soon, sir. Thank you for joining with us.
We'll do. When we meet next time, hopefully we're all completely vaccinated.
Yeah. Thank you so much, sir.
Please stay safe. Thank you, Dr. Anil.
Thank you. Thanks. Thank you very much.
Thank you, Anil sir. Thank you, Anil sir.
So moving on to the second session. The session is handled by Engineer Praveen Muley, the Tunnel Engineer, ARCADIS Singapore, on the topic Underground Infrastructure in Singapore, chaired by Dr. Jimmy Thomas and co-chaired by Adulya GS of first year MTech batch. Dr. Jimmy Thomas is a consulting engineer specializing in geotechnical engineering, geosynthetics, reinforced soil structures, and pavement engineering. Dr. Jimmy is presently an executive committee member of Kochi local chapter of Indian Geotechnical Society, member of ISS MGE TC 213 on score and erosion, and vice president of International Geosynthetics Society Indian chapter. He has been elected as National Executive Committee member of Indian Geotechnical Society for the term 2021-22. So now I welcome Dr. Jimmy sir for giving the introduction about today's speaker.
Yeah, thank you very much and good afternoon. It is a great pleasure to be here in this wonderful technical event. First of all, I thank the organizers, Marine Engineering College and the student chapter and IGS Trivandrum chapter for inviting me to be associated with this technical event. Today we have an eminent engineer, Mr. Praveen Muley, who is working with ARCADIS Singapore, specializing in tunnel engineering. Mr. Praveen Muley graduated with bachelor's degree in civil engineering from MIT Pune in 1998. He obtained his master's in structural engineering also from the same college. Mr. Praveen Muley began his career as a structural engineer and worked in the design of various buildings, retaining structures, factory structures, and foundations of various structures. He taught in engineering colleges also for some time. Presently, he is with ARCADIS Singapore and he has more than 11 years experience in NATM tunneling. He specializes in sprayed concrete lining design and supervision of NATM tunneling works. He was a project officer with Nanyang Technological University of Singapore, where he worked as a consultant to the prestigious JTC Jurong Rock Cavern project. Mr. Praveen's experience in underground infrastructure and tunneling includes underground construction projects such as Jurong Rock Cavern, deep tunnel and sewerage system, working with building information modeling to improve and innovate design solutions for his project. Currently, he is working as the sprayed concrete lining system designer's representative for the DTSS2 project, which comprises 12 km of TBM sewerage tunnels, 4 slurry TBMs in operation, and 14 shafts and 9 NATM caverns and tunnels. So we have a highly qualified, highly experienced civil engineer with us to share his experiences. So today he will be sharing his topic will be on underground infrastructure in Singapore. So I invite Mr. Praveen Muley to start his presentation.
Thank you, Jimmy sir. Respected professors, guests, and dear students. Let me share the presentation. Okay, can you see my screen?
Yes, sir, it's visible.
Just hold on.
Sir, it's visible, sir.
Yeah, I'm sorry, my other screen was not visible to me properly.
Okay.
Yeah. Okay, good afternoon, everyone. Today I will be presenting before you the underground infrastructure, some case studies in Singapore. Mr. Chandran, he has given you in-depth knowledge about the Bugis station, but here I will just go through the different projects, infrastructure projects, so that the students, they will come to know what are the infrastructure activities going on in Singapore, and it may inculcate some insight in them about the underground activities, and they can think on taking this work which is going on in Singapore seriously, and then they can try working in Singapore or elsewhere with this knowledge. So my presentation brief will be having this underground structure in Singapore, and I will discuss briefly about the Singapore geology, then a couple of projects like Jurong Rock Cavern, then DTSS2 project, and then Cross Island Line. There are many projects which are underway, but I'll just briefly discuss about this few. Now, when you're thinking about the mining, what do we mine for? We mine for the minerals, metals, precious metals, gold, silver, copper, etc. Sometimes we mine for the diamond also. But here in Singapore, do the Singapore mine for the minerals or the wealth? No, the Singapore mines for the space. Singapore is a small island with around 50 by 40 square kilometer. So it is not a very big island. So space is always a constraint. So Singapore is always looking for the space creation. So it cannot expand horizontally. There are limitations because of the sea, and on the other side, the Malaysia. So they mine underground. This is a Senkaku Island. This is totally in this portion is landfill, and they are going to infill this side also. And 2,100 tons of incinerated waste, which is generated in Singapore, they compact it in terms of the blocks, and then they dump it inside this one. They have this boundary over here, boundary walls, and they are putting it inside. They're filling the sea line, and they will be creating this island. So especially now the Singapore is mining for space. So create the islands or go underground. Now, if you study the rock cycle, you can see this magma comes up to the surface and it becomes the igneous rock. And because of the sun and the rain, it erodes and get transported and go into the sea and get it deposited. And with the deposition on layer upon layer and with the pressure, and over the millions of years, it becomes a rock, solid rock, and this becomes a sedimentary rock. With the pressure and high temperature, it becomes a metamorphic rock. So it can come up to the surface or join it to the mantle or this magma and come up as a igneous rock. So basically in Singapore, you will find this sedimentary type of rock most prominently, and the igneous rock. So if you see the geology of Singapore, so you will find this one is granite. This red one is Bukit Timah granite. This is the Bukit Timah area, and you'll find this granite over here. This is a sedimentary zone, and these are the different formations, like Kalang Formation, old alluvial soil, Fort Canning beds, etc. So this dates back to around 500 million years back to the till date. So the formation of geology is ongoing. So basically here, if you simplify, the geology of Singapore is Jurong Formation and Bukit Timah Formation mostly. This is the Sajat Formation, which is the what we can say the oldest formation in Singapore. If you simplify this one, we can see that this is the Jurong Formation. This is Bukit Timah granite. So we say this because of this Bukit Timah area, we say this as Bukit Timah granite. So this is Bukit Timah granite. And for our civil engineers or geotechnical engineers, this is how we consider this island as a sedimentary rock, then igneous rock, old alluvials, and then other sediments over here. And okay, so we come to know about the geology based on the boreholes. Now in Singapore, we have the Nanyang Technological University and Building Construction Authority. They are undertaking some studies. They are collecting the borehole data and placing it on this map. And they're preparing this borehole logs here. These borehole logs are prepared based on all the shallow borehole data and the deep borehole data. So they have created this one, and they're matching it depending on the line where we have these boreholes. And from this one, there is interpolation matrix they're using, and then creating this model. So this particular area, if you have this one, if you have this borehole data along this line or along this line, we can create the 3D geological map. And then this 3D geological map is sent back to this one. So based on this one, you can find out at any particular point. Let's say if you click onto this point, then you can get the geology of this particular area. It means maybe up to 50-meter depth or 100-meter depth, depending on the available data. So if you see here, this is a shallow one, this is a deep one, and it is having the different layers of the soil or the rock formations. Now, why they are doing it? they want to do it, develop this as an internet-based platform to work out the geology, to find out the borehole. So if in future, if there is any future project coming up, they can just draw a line, let us say from A to A dash, and then they can come up with this this geology. Okay, so they need not to go for the physical bore log for each and every station. Suppose they have to, if somebody has to construct a building of let us say 100 meter by 200 meter area, then they have to do the soil investigation. It takes a lot of money to do the soil investigation, borehole log, and all these things. So if we have this facility and the technology that by just drawing a line, you can get the geology based on the earlier history of the borehole log, that which is being put it into this map by this BCA and you, then we can just get this information. Of course, we have to pay to the BCA, that this service will not be free of cost. So you can come up with this geology 3D view, or you can come up with this random cross sections with the different geologies, and then you can base your excavation, let us say from here to here, and then we know this geology, and then you can plan or you can take a very good and informed decision on how to excavate that area, how to go with the deep excavation in that particular area for construction of any building or other infrastructure. So this will be very important tool that will be developed by this BCA. This is called as Underground Singapore. So if you see this underground structures in Singapore, there are different layers of Singapore, different layers of utilities and the facilities which are being constructed underground in Singapore. So if you see this small area over here, it can accommodate many facilities like these substations. In India, we see that the distribution poles or electrical poles, those are on the roads side, on the side of the roads. But in Singapore, of course, in India, some major cities you will not find it on the surface. There is also underground electrification. But here, if you see it in Singapore, it is all underground. The distribution poles or the substations are underground. Like in India, we see the electrical wires which are running from pole to pole, from house to house, which will not be seen here in Singapore if you come. There are some pedestrian links which are connecting the metro stations to the malls or surrounding areas. Then if you go to deeper, then you have this different utilities like the water pipes, then the gas pipes, etc., which are running under the ground. Now this is the special thing in the Marina Bay area, which was used, this tunnel, in which the cold water will be sent, and this water will be sent it to the entire building, and the air conditioning will be working based on these pipes. So instead of having the aircon system for each and every building or each and every floor, then they will here they're using it these pipes, underground pipes, which helps to provide them the cold water, which will in fact will reduce the temperature of the building. Then we have the MRT structure. If you go deeper, then we have this some passages. Then if you go deeper down around 50-60 meters, we have this deep tunnel sewerage system. Then if you go again deeper, we have this Jurong rock caverns, which are constructed on the Jurong Island. If you again go to the deeper, then we have this ammunition storage facility. And Singapore is also again planning for the underground reservoirs, which will help them to store the water during the droughts. Currently, Singapore is purchasing the water from Malaysia, So up to 2061, they have the this agreement, but we don't know the geopolitical situations, how it can unfold in future. So Singapore is thinking of having their own water reservoirs, which we can help them to store this water and use it for the domestic use. So let's go to the projects. For this one, DTSS, that is a deep tunnel sewerage system. This is the phase 1 from the Changi water reclamation project. Over here to this point is the phase 1, and from here is the phase 2. So this is the south tunnel, which is having around 6-meter diameter, and there are some link sewers also coming up to this one. And here we have this Tuas reclamation, Tuas water reclamation plant over here. So we have this 3 WRPs over here in Singapore, 1, 2, 3, which collects the water, which is sewer water, which are coming from these sewers or these sewer tunnels, and then they will treat it, and they will send it back the water to the reservoirs, or if it is a wastewater, then they can treat it and send it to industrial zones, or otherwise, if it is not possible, then they can send it to the sea, deep into the sea. So for the this DTSS2 project, if you see, this is a 50-kilometer long tunnel, and it will be completed up to by this 2025. It is around $6.5 billion project. There are 5 contractors working for this one, for this phase 2. The 3 tunnels are going under the subsea. Some are the rest of the tunnels. Those are going under the land, and some 3 tunnels are going under the sea also. So there are 19 tunnels. 19 tunnel boring machines with the various diameters ranging from 4.3 to 7.66 meters. So with this project, the estimated soil excavation is around 1.8 million cubic meter, which is very, very high, with the help of this 19 TBMs and excavation of around 50 shaft sites. So the entire DTSS2 program frees up precious land around 214 football fields. Like I said, that what the Singapore mines for, it's mines for the space. So it always talks in terms of the space. For the DTSS2 tunnel project, we have the tunnel, TBM tunneling. So the TBM tunneling is with the 1, 2, 3, 4, 5 plus this one. So 5 plus 1 segments of the tunnel. So around 300 mm thickness of this segment. Then we have this inner secondary lining. So this inner secondary lining is MIC resistant concrete as a microorganism induced corrosion resistant lining, because this sewer will be carrying the wastewater. So the inner lining should be resistant to the chemicals and the bacterial activities. So that's why they are using this MIC lining. Again, more to that one, they are using this HDPE linings. So this HDPE lining is around 2.5 millimeter thick lining. Here you can see this. The green one is this is the formwork for the this inner lining. So this one is cast in situ. The upper one, when this is excavated using the TBM. So as the TBM progresses, these linings will be installed. So you will have this precast segment linings. After the TBM goes, then this formwork will come into place, and they will install this HDPE lining, and then they will be pouring this concrete behind this one. And this is the formwork which is being used over here. So here in this picture, you can see this formwork in action. So this is the segmental lining, then this formwork, and then you have this inside this cast in situ inner lining, which is MIC lining. For the sections which undergoes the sea, we need to take care of the water. So there is extra lining over here, which is waterproof lining. Okay, so one membrane will be put it over here before putting this, before casting this cast in situ lining. So after the precast lining, there will be this waterproof liner will be placed, and then this cast in situ lining with the HDPE. For monitoring of this entire sewerage project, DTSS2, there will be 1 to 3 locations where they are installing the fiber optic sensors, which will be running throughout the length of the this DTSS2. If you see typical geology, as I said, why I have shown this geology is to come to know what is the type of geology we come across. So this is a Jurong formation. Jurong formation is nothing but the sedimentary rock, which is nothing but the soil placed layer after layer after layer. So we don't know how it behaves. And this is again a Jurong rock formation, which is consolidated enough, and it is as S3, S2, and S1. This is a good quality rock, and this is S6, S5, S4. We can treat it as a soil. So based on the boreholes, we come up with the profile, a geological profile along the entire length of the tunnel, and we see how this based on these boreholes, how the geology will change. Now this TBM is going from here, and it is going to this this hard rock to the soil. So this is a mixed phase, and from here, this is the area. This is the area where it is a mixed phase. So this mixed phase is very interesting thing, because we don't know whether this soil above will be stable or not. So this is very critical section when the tunneling, when you are mining through this typical geology. So these sections are very important as far as the TBM operations are concerned. And here in Singapore, the Building Construction Authority, which controls all the excavations in Singapore, or rather all the construction in Singapore, they do not allow the tunnel boring machine to stop within this zone, within this mixed phase zone, is because we don't know whether this area will be stable or not. It may so happens that if you stop this TBM over here, it will be half in the rock, half in the soil. The soil may come down. So it is difficult for us to maintain the phase pressure of the TBM over here in this particular area. The other thing what can happen is that because of the this mixed phase over here, if you stall the TBM, if you stop this TBM over here for, let us say, cutter head intervention, then okay, cutter head intervention means you stop the TBM if there is any fault, or if the progress is not good, you stop the TBM, and then you see whether your cutter heads, the cutters are working properly or not. If they are eroded or not working properly, then you need to replace it. So for maintenance purpose, we stop the TBM. So that is called as cutter head intervention. So if you stop it here, half is rock, half is soil, and then you cannot maintain the pressure. So what happens? The soil above it, there may be a settlement. If you see this tunnel alignment, we have this building over here. If the building settles over here, then it is a big cost to the Singapore or to the contractor and to the owner of this project. Now this DTSS2 is being the owner of this DTSS2 is a public utility board, so it is a government organization also. So you cannot stop it here. So if this building settles, the consequences are very high. Another issue is that the water drawdown, like Mr. Chandran says that it's you cannot means the government doesn't allow us to water drawdown of 1 meter, more than 1 meter. In Singapore, if you see the water table, it is almost 1 to 2 meter below ground. And when you are designing, we consider this as at the ground level for the worst case scenario. And you cannot allow water drawdown more than 1 meter. So if there is water drawdown in this area more than 1 meter, then we are in a big mess. And then we have to stop this work. We have to attend to the BCA, inform it to BCA that things have happened. Then we have to do the grouting from this space, okay, etc. So it incurs extra cost, and the consequences we don't know what will happen. The building will settle, or building will further lead to collapse or something. So that's why we don't. The government doesn't allow to stop this one. So this geology is along this entire length or the stretch of this tunneling is very important. And these boreholes are almost around 50 meter apart, not more than that. Sometimes we can have the boreholes at 30 meters also, 30 meters apart also. The another specialty for this DTSS2 is that it not only carries the wastewater, but it has the other facilities also, like air jumpers and odor control facility. So if you see, this is a tunnel, and this is a link sewer. Link sewer means it is a small tunnel which is already carrying the wastewater, and we are connecting this sewer to this tunnel. So this was constructed earlier, and now this is a new tunnel. So we need to do the connection over here. So how we do the connection is through the drop structures. So this link sewer, this wastewater will come to this drop structure, and we have this deaeration chamber over here, and this will connect it to the tunnel. Okay, so sewer tunnel, and this is the vent pipes which will allow the odors to come out, and this will be collected over here in this odor control facility. It will be treated here, and it will be send it to the atmosphere, or it will be send out. Now there is another thing, that is the air jumper. So sometimes when this sewer is coming here, connecting to this one, similar arrangement, but because of the low pressure, low pressure in this tunnel, the air may not go. So here they are going to pump the air, so that this air will be carried with the sewer. So this air will be carried, and it will be sent to the next station where we have this odor control facility. So this air will be collected, or the odor is collected over here in this odor control facility. Okay, let's go to the another iconic project which Singapore had, is that this in early 2010s there is an area which is known as Orchard. So in this area, because of the storms, there will be heavy rains, and if it rains for 40 minutes, and then you can see this area is completely flooded. So to take care of this flooding in this particular area, what they have done is they have constructed this Stamford detention tank, and this detention tank is this one. It's around 38,000 meter cube of stormwater it can store. So this is the canal they have already, and this is the diversion tunnel. Okay, So this, if it is used over here, it will be because of the storms and the heavy rains, this area in the orchard will be flooded. So what they have done is they have already first diverted this area so that this catchment area will be covered by this diversion canal, and this area will be less flooded. Some of this water they are absorbing over here. So whatever the water, they put the gate over here, so water will go from here to this detention tank, which is around 30-meter underground, and it will store around 38,000 meter cube of stormwater, or we can say that 15 Olympic size pools, swimming pools of water it can store. And when the storm subsides, then it can release this water back to the channel. So I can if you allow me, I can play a video of 2 minutes. Is it okay to show the construction of this one?
Yes, Mr. Praveen.
Yes, sir. Yes.
Expected to continue with climate change. In order to cope with more intense
It was playing on my screen. So okay, can you see this one video?
storms and reduce flood risks, Singapore's
Yes, sir.
Okay, can you hear?
Yes, yes, we can hear.
Yeah.
The Stanford Diversion Canal and Stanford Retention Tank are drainage projects that were designed to improve stormwater management within the Stanford catchment area.
Due to space constraints, UB was unable to widen or deepen the existing Stanford Canal without causing great disruptions to businesses, motorists, and pedestrians at Orchard Road. The solution was then to construct a diversion canal to divert excess stormwater and a detention tank temporarily collect and hold back excess stormwater during heavy rain events.
To build the Stanford Diversion Canal, engineers constructed 1 kilometer of box columns ranging from 7 to 14 meters wide. A pair of 1 kilometer long tunnels were also constructed in densely built up areas to minimize disruptions to residents and motorists. To build the tunnels, a 14-meter deep shaft was first constructed. A 100-meter long tunnel boring machine with an excavator base of 5 meters in diameter was then assembled in the shaft. As the tunnel boring machine digs through the soil, it lays concrete segments to form the tunnel.
Previously, the stormwater runoff from upstream areas such as Colonel and Napier Road areas would flow into the Stanford Canal sited under Orchard Road. With this new diversion canal, stormwater runoff from these upstream areas will be channeled towards the Singapore River, therefore reducing the load on existing Stanford Canal.
The second drainage improvement project for the Stanford catchment involves the construction of a detention tank underneath the Tyresol Learning Forest and National Orchid Gardens nursery to retain the excess stormwater. The tank draws water from the existing drain along Holland Road. An overflow wheel with 6 5-meter wide gates was constructed to control the amount of water to be diverted into the tank. Pipe tracking machines were used to build a pair of 2.5-meter diameter pipes that connects the tank to the overflow wheel.
By holding back excess stormwater during heavy rain event, the Stanford detention tank will slow down stormwater that enters the Stanford Diversion Canal. This automated facility can collect and retain 38,000 cubic meters of stormwater, which is equivalent to the volume of 15 Olympic-sized pools. After the heavy rain subsides, the tank will release the water back to the empty trains.
The Stanford Detention Tank and Stanford Diversion Canal are all-encompassing engineering projects that were realized with the dedication and hard work of the engineers. With the completion of the Stanford Detention Tank and Stanford Diversion Canal, we can now divert 30% of the stormwater away from the Stamford Canal, thereby lowering the flood risk to the Portugal area. Projects such as these are testament to PUB's commitment to continuously improve our stormwater management and infrastructure to enhance flood protection for Singapore.
Okay, so this is a Stanford detention tank. Now, another project that is Jurong Rock Cavern. This is also a typical, this is also an iconic project which is constructed on the Jurong Island in Singapore. Mostly this island, if you see, it's backfilled, just like the Sam Kako Island, which I have shown. This is the backfilled island. Can you see this cursor?
Yes, we can see.
Yeah. Okay, so this this Jurong Rock Cavern, if you see this area, these are the oil storage tanks. With the, if you see the specifications, they're very stringent. You have to keep a safe distance between two tanks, and this tank can be around 15-20 meter wide by 15-20 meter tall maximum, or some short tanks also, and it will take a lot of space. If you see, a lot of space has been consumed over here. So to save the space, what have Singapore done is to go underground. So by using this Jurong Rock Caverns, constructing these two Jurong Rock Caverns, they have saved around 60 hectares of the surface land. Now, there are some terrorist activities also going on in the area. So it's even these facilities over here, if they are attacked by these terrorist activities, then it will be a disaster for the Singapore. You know, this Singapore island, you can means a common man cannot go. Only those who are authorized can go to this one. So you have to take the pass. If your company is working over there, or if you are going for some inspection, you have to get the prior permission to go to these islands. There are different big companies working on here, but it is not open to the common people. So to take control of this terrorist attacks and all these things also, it is very important for Singapore to store this oil underground. Similar projects have been there in India also. There are 6 to 8 underground caverns which are used for the storage of the oil. Okay, so it is saving the surface land. It is improving the security, and it is improving the health and safety also. So this is the first phase of the Jurong Rock Cavern. So if you see this Jurong Rock Cavern, it is around 20 meter wide by 30 meter tall. So it is almost a 10-story building, and this is having the capacity to store 1.65 k meter cube of the oil. So if you see this yellow here, this portion is nothing but this Jurong Rock Cavern. Okay, so these are twin caverns. So this is one cavern over here, and this is another cavern. So these are two interconnected over here. Now, if you see this length of this one, if you see this is 20 by around 27 meters. So, and this length is around 340 meters. So you can think of how the enormity of this project. This is the water curtain gallery. Okay, so this from this access shaft over here, we have the adits and tunnels. You go around 120 meters down, and then we have this tunnels. This is the access tunnel over here. Sorry. Okay, so this is the access tunnel over here to this one. And then this is the water curtain gallery tunnels. And through this one, they are sending the water under the pressure. So we have this water curtain galleries over here. Between the two caverns, we have these water curtains, and this water under pressure, which will keep this whatever the oil which we are storing, which are escaping inside this one. So if the oil is trying to escape to the surface, this water pressure will keep them inside this tunnel, inside this cavern. And moreover, this entire structure is under sea. So the entire area over here is nothing but the sea. Here on this another side of this landfill is this access shaft 3. So we have these two shafts, one here and another here. So we are controlling the access and ingress of this facility. So these are the operation tunnels over here, and this is the access tunnel over here, water curtain galleries. Then these are the caverns which are used for storing the oil and naphtha, etc. So this is another project. What happened to this one? I think missed out some presentation slides. I think should be okay then. Okay, so this is the Jurong Rock Cavern Project 1, and this is the project number 2. So yeah. Okay, then I can conclude with my presentation over here. Thank you very much. So do you have questions for me?
Thank you, sir, for the amazing and very informative session. Now the session is open for doubt clearance and feedback. Anyone from the participants are invited for the same. You may use the chat box or you can unmute the mic. Anyone from the participant side? Is there any feedback or queries?
Good evening, sir. I'm Janita. I'm pursuing my first year MTech in Geotechnical Engineering. The question that I would like to ask is, how does the deformation pattern of an underground infrastructure during an earthquake change if the depth of the tunnel increase or something like that happens?
Yeah, very good question. If you see, as far as India is concerned, India is divided into the different zones, 1, 2, 3, 4, 5 zones, correct? But and the India in the northern part of the India is falls under the seismic zone. But in Singapore, if you see the earthquake, there are nil. The Java Sumatra Islands on the other side of the island, the most of the earthquakes happen. Okay. So this Singapore is under the shadow of the earthquakes, and there are very less possibilities for the earthquakes to happen in Singapore. So most of the designs in Singapore, we do not much care about the earthquake, or even though we consider the earthquake, it's a minimal one. So in our studies, frankly speaking, we don't consider much. Okay, so coming back to your question, sorry, I missed out your question. Can you repeat your question?
Sir, is there any deformation pattern of any underground infrastructure during an earthquake change if the depth of the tunnel increases or something like that happens?
If you see the earthquake, the surface structures, if you see a tall building, let us say 50-story building, okay, and if there is earthquake, so earthquake will have two waves, primary waves and secondary waves. Forget about the primary waves. Secondary waves are most destructive, which will cause the horizontal movement. Okay, so if you see this 50-story building, you can see it works as a cantilever structure, correct? So cantilever structure is the more bending at the top or at the free end. Okay, so the deformation or the movement will be more at the as you go up. Okay, so the deformation or the movement for during the earthquake is more for the above ground structure, but if you see the underground structure, mostly they are intact. If you see most of the earthquakes, they are intact as compared to the surface structures. But again, if there is a severe earthquake, it depends on the geology. If your tunnel is in the intact rock, so the intact rock, it will move completely. So there will not be any deformation, or there is not much movement of the tunnel, even though it is shallow or it is a deep. The second thing, if the tunnel is deeper, and if you come in the fractured rock, of course, then the severity will increase if you go deeper into the soil, deeper into the rock, if the rock is fractured. I can have a separate presentation on the failures of the tunnels due to the earthquake all over the world. Yeah, but of course, if you consider the caverns, we decide the place where we are going to do based on the borehole, whether the place is safe or not, whether there is any active fault or not, whether it is earthquake prone, and then we consider these caverns. But for the tunnels, we have to go from one end to another end, so that we cannot control. And of course, as you go deeper, the earthquake effect will be more if in the fractured rock. If it is intact rock, no issues.
Yeah, there is a question. There is a question from Sanjay Gupta. What's generally the depth of the rock? Yeah.
Wait, sorry. What is the question?
First finish the dhokla, then you will.
What is the depth of the rock generally?
I mean, for instance, you have this storage part. So in the storage, you have shown the cross section with the rock and the soil, right? So what is generally the depth at which we get rock in Singapore area?
Singapore, some areas, now I'm working for this DTSS2 project, which we have the shafts around 60 meter deep, and we have not come across the rock. Okay. But at some locations, we have the rock around 40 meters deep.
Okay. So that means, I mean, generally I can say that the minimum depth of rock is 40 meters.
Yeah, 40 to 50 meters you will find the rock. Yes.
Okay, right, right. Thank you. Yeah. Right.
So, Praveen, I have a question.
We have a question from the chat box of YouTube. What is meant by mixed soil? Does it mean weathered rock?
Sorry, mixed?
Yeah, what is meant by mixed soil? And does it mean weathered rock?
Oh, mixed ground. Mixed ground, I was saying. Mixed ground means if the soil is there and if the rock is there. Okay. So in that case, what happens? The phase pressure, maintaining the phase pressure is difficult. It will the phase pressure will be lost. You cannot maintain. So there may be chance of the phase collapse. Sometimes for the mixed phase, if you're boring and there are some boulders coming, so let's say boulder is of size of 1 meter by 1 meter, and if you're trying to bore it, and the entire other area of the face is say soil, and this boulder is 1 meter by 1 meter, means it is boulder means a rock 1 meter by 1 meter. Then if you try it to achieve the this rock boulder, it will not be achieved because the boulder is stronger and this soil is soft. So as you go progress, this boulder will just keep on turning along with the movement of the TBM shield, TBM cutter. So this is the mix phase, what I was saying. Have I answered the question?
Yeah, I think it's clear.
From the participants?
Yes, sir. Jimmy, sir, you were asking some question?
Yeah. See, like we have seen the potential of the underground, but it is mostly for infrastructure, utilities, or storage.
Yeah.
Like, do you see a possibility of underground living spaces in the near future, like people living underground?
Living spaces. We have the project of Science City in Singapore, which is underground park, and that will be used for the offices, science parks, laboratories for testing. So now Singapore is thinking of in that way, which will see whether with this science city project, whether people can live in the underground for 8 to 10 hours. If they can live for 8 to 10 hours, then the next project will be underground buildings, and then they will see how it goes. Already they have undertaken the studies during the excavation of this JRC with this the workers which were working over there. How do you feel going 120 meters below the ground? Whether there is any psychological effect, because the entire period of time you don't see a natural light, you don't see the natural ventilation. So it is always the artificial air which is being pumped inside the tunnel, and it is always the floodlights which are being over there. So the studies are still going on. So the first step is to go with the Science City project, which will make people to work for 8 to 10 hours, and then definitely yes, air conditioned underground spaces will be there.
Okay, thank you. Like one more question. Of course, it's not a technical question. Like what is the ownership? That means my question is if a private person owns a land, to what depth is his right ownership?
It's up to 30 meters.
Okay, 30 meters. Below that, it is public.
It's a government. Yeah, most of the property, around 85% of the property, is governed by the government. 85 to 90%. You can see in Singapore.
Yeah, one question. In continuation with Jimmy sir's question, has any comfort study been done on people who go to work below, like temperature, air quality, overall comfort? Any comfort study been done?
Yeah, this is what I was saying, that the studies were done for the Jurong Rock Cavern for the workers which were working underground for 6-8 hours. And the people, those who were involved in that one, like I was there to work there, but I will not go as a worker for 8 hours, but I will go there for the inspection and all these things. So again, different categories of people, they will take these studies. Like the workers, they can sustain harsh environment for more period than me. If there is some other person who is having the, what we can say, the fear of the spaces, claustrophobic, then he may not be able to sustain in that particular area or underground. Yeah.
I think one of the speakers referred to an open underground area which was suitable for holding big meetings and all. During the series, I heard someone telling about that. Was it yourself or somebody else? I don't remember. In Europe, some facility was there. Somebody was.
Europe, they have the sports stadium.
Yes.
Yeah, we have the sports stadium. They have built under the ground for 2004 Olympics. Especially, they have constructed this one. Yeah, so we have these facilities. In Singapore also, we have these malls and all these things. Those go around 10-15 meters below ground, and no issues. The MRT stations are also around 30 meter below the ground, and we have the shops over there. Some food courts are there. Food courts means the chain of some small cuisines, and people go there, eat there, no problem. But like Jimmy sir was asking whether people can live there, yeah, that's a different domain. If you ask me to go and work, I can go there, work for 2 hours, 8 hours, 10 hours, and then it definitely my natural habitat is above ground. So I would love to live on the land.
Thank you.
Yeah.
So anyone more to share their feedback?
Good evening, sir. I am doing my master's in geotechnical engineering. This session was very enlightening and relevant. It added to my understanding and knowledge more about the underground infrastructures. It was an informative session within a short duration of time, and it has made us more aware of the tunneling process. I would like to thank you for the valuable time you have spent on sharing the information with us. Thank you, sir.
Yeah, thank you.
Thank you.
Myself Gobika. I'm doing masters in geotechnical engineering. Sir, this was a staggering session for me. Your presentation was really enlightening one. I got an idea about the infrastructural activities on Singapore, and the two case studies which you discussed were good. And also, I much appreciate for the mind-blowing section, and also for sharing your time and willingness to share your information with us. Thank you, sir, for taking such an informative section. Thank you.
Thank you.
Good evening, sir. I'm Anjima. So the session was very informative and was very nicely presented. It was really interesting. It helped me a lot to get to know about infrastructural activities in Singapore. Thank you so much, sir.
Thank you.
Anyone more to share the feedback? So I hope everyone is clear. So now I request Praveen sir to stop the sharing so that we can share our screen. Okay, thank you, sir. So now, as a token of gratitude and appreciation, we would like to present a virtual memento to Praveen sir. Yes, the memento is presented in the screen, sir. This is presented to Engineer Praveen Muley with deep appreciation of your visionary guidance and in grateful recognition for your enduring commitment throughout the symposium. We thank you for spending your valuable time with us. Thank you, sir.
Thank you.
Now, I invite the session co-chair Atulya to propose the vote of thanks.
Am I audible?
Yes, Atulya, you are.
Thank you, Hemna. As all the good things come to an end in life, so this session too. A lovely and warm evening to our most valued and worthy guest, management committee, respected teachers and beloved friends. It's a matter of pride of me that I am proposing a vote of thanks for this session. I, on behalf of this entire IGS student chapter, first of all spread my most sincere thanks to the speaker of the day, Engineer Praveen Muley, who gave his vital time from his busy schedule and provide us with immense knowledge. Thank you very much, sir, for this informative session. I would also like to extend my sincere gratitude to the session chair, Dr. Jimmy Thomas, for your unflinching support and coordination. Further, a big thanks to Hemna for her effort towards today's anchoring. I also want to thank all the dignitaries and faculty members for their cooperation in this session. We are fortunate to thank the dedicated and well-motivated IGS team of our college who are aware of their task and very concerned about the results. There is much waiting on the vote of thanks to express my emotions that correctly fits the atmosphere. So, I show appreciation to the students and the management who have been the strength of this session through their active participation. Once again, I would like to state that we are glad to each one of you over here. Thank you. Have a great day ahead.
Sir, we have one more question in the chat box. Can I read it out? Hello, sir. Are you audible?
Yes.
Sir, is there occurs any negative impact on the environment due to underground constructions?
Yeah, for any type of construction, there will be a price to pay, definitely. No one can deny this one, no one can hide it one. But then again, we have to see the plus and minus. So, of course, there is environmental impact. But if it can be used for the betterment of the human, yeah, definitely we have to. But it is not that great that it will cost catastrophic issues.
Okay, thank you, sir. And thank you, Jimmy, sir, too. So the participants, please note that the feedback form of the second session is shared in the chat box. All participants, including officials and faculties, please make sure that you fill the feedback form.
Thank you, Jimmy sir and Praveen sir. Can you please on the video so that Praveen sir, I think participants have not seen you.
Yeah.
Praveen, please, can you on the video so that they all can see you there?
Hi. So, hello, friends.
Thank you, Praveen
Yeah,
sir and
thank
Jimmy
you.
sir for sharing your time with us, and thank you. In this busy schedule, you have joined with us, and really thanking once more Praveen sir to join Marine Energy College. He already took a section on underground caverns, and I think Sanjay sir also on the screen. Thank you both of Jimmy sir also spent a valid time with us, joining us to support the Marine College. Thank you so much, sir. And I hope we'll move on to the next part of the program. And again, I hope to have sessions from you, Praveen sir. Again, Jimmy sir will make you in contact, and we will contact you again and again for our student chapter.
Yes.
Thank you,
Yeah.
Praveen sir.
Thank you, everyone.
Jimmy.
I will take a leave now. I have to go. Yeah. Thank you.
Sure. Thank you very much.
Yeah. Thank you, sir.
Thank you, sir.
So now we'll commence the cultural programs shortly. So now the waiting is over. We are moving on to the most awaited event of the day, Contact 2020. As we know that we are in a pandemic situation due to COVID-19, so we have planned the programs via online. So the students of Civil Department of both BTech and MTech of Marine Engineering College took much effort to make it more colorful. So if there is any kind of flaws or issues in our side, please do forgive and hope all the participants will give much support and encouragement to our students to make Contact 2020 a more successful one. So let's start the program with the blessings of God Almighty, prayer song by Abarna from S3 BTech.
Sri Kananada Sindhura Varna Karuna Sagara Karivadana Lambotara Lakumikara Ambasuta Amara Venuda ലംബോദര ലഘുമികര സിദ്ധചാരണ ഗണസേവിത സിദ്ധിവിനായക തേ നമോ നമോ ലംബോദര ലഘുമിതര അംബാസുത അമരവേണുത ലംബോദര ലഘുമികര സകല വിദ്യ ആദിപൂജിത സർവോത്തമയത തേ നമോ നമോ ലംബോദര ലഘുമിതര അംബാസുത അമരവീണുത ലംബോദര ലഘുമിതര.
Thank you, Abanna. Now we have a beautiful song from Pooja Ajin of S5.
Hello, it's me Pooja Ajin from Civil Department. I'm here to sing a song for you. I'm not a good singer, so forgive my flaws. Let's enjoy together. मैं तेरू समझावा के ना तेरे बिन लगदा जी मैं तेरू समझावा के ना तेरे बिन लगदा जी तू की जाने प्यार मेरा मैं करूँ इंतजार तेरा तू दिल तो यूं जान मेरे मैं करूँ समझावा की ना तेरे बिन लगदा जी കൺചിമ്മിയോ നെഞ്ചാലകം ഏതോ നിഴൽ തുമ്പികൾ തുള്ളിയോ കാതോർക്കയായി നിൻരാവുകൾ കാറ്റായി വരും നിന്റെ കാൽത്താളവും തങ്കത്തിങ്കൾ തേരേറി വന്നപ്പൂവിൻ തേൻ തേടി പിരിത്തുമ്പിൽ കൈമാറും മോഹങ്ങളിൽ ഇന്നും തന്നെ കൺകോണിൽ മിന്നും പൊന്നായി കാത്തോളം പിന്നും മിണ്ടാതിന്തേ നീ നിൽപ്പൂ മുന്നിൽ तू ही है मुझको बता दे चाहो मैं आना अपनी तो दिल का बता दे चाहो मैं आना इतना बता दो तुझको चाहते अपने मुझको यूं तो नहीं दिया फिर भी ये सोचा दिल ने अब जो लगा हूँ मिलने पूछो तुझे एक बार तू ही है मुझको बता दे चाहो मैं आना अपनी तो दिल का बता दे चाहो मैं आना.
Thank you, Pooja. Next, we have a semi-classical dance performance praising Lord Ganesh from Gopika of first year MTech.
तदसुतं तमिह श्रीविघ्नराजं भजे सन्ततमहं दन्ति सुन्दरमुखं मन्तकातदसुतं तमिह श्रीविघ्नराजं भजे
श्रीविघ्नराजं भजे
श्रीविघ्नराजं भजे
श्रीविघ्नराजं भजेऽहं 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 भजे तमिह श्रीविघ्नराजं भजे सेवित सुरेन्द्र महनीय गुणशीलम्
सेवित सुरेन्द्र महनीय गुणशीलं जप तप समाधि सुख वरदानुकूलम्
भावित सुरमणिगण भक्त परिपालम् भयङ्कर विशङ्गमातङ्ग कुलकालम् श्रीविघ्नराजं भजे श्रीविघ्नराजं भजे श्रीविघ्नराजं भजे
Thank you, Gopika. Next, we have an amazing song from Georgie C. Jacob of S3 BTech. The highlight of the program is that this song is written and composed by Georgie himself, and he also have an YouTube channel, a Spotify channel, and also in Amazon Music. So hope you would like it. Sit back and enjoy.
Wish I could just go back to when I was 14, when I was in between me and you that I wanna be. Maybe I shouldn't go back to when I was that young. I like the person that I finally turned out to be. Everything around me feels so heavy, I'm so done. I sometimes feel like giving up, but that's not who I am. The world inside I get me out, it all gets so bad. Your expectation, you are like a bullet in my head. Tell me, how did I get here, get here? I don't feel the same always. I'm going through some changes, I'm going through some change. How will I get there to a better place, please help. I'm going through some changes, I'm going through some change. I did not need it, I did not demone, I did not now I'm 19, feel like 14. I can walk away from all the demons in my head. They keep dancing in my head. The wall that I have built is falling into pieces. I am picking up all those broken pieces to fix me. Everything around me feels so heavy, I'm so done. I sometimes feel like giving up, but that's not who I am. The world inside I get me out, it all gets so bad. Your expectation, you are like a bullet in my head. Tell me, how did I get here, get here? I don't feel the same always. I'm going going through some changes, I'm going through some change. How will I get there to a better place, please, yeah. I'm going through some changes, I'm going through some change. I did not easy, I did not demo, I did not down on my knees, yeah, down on my knees, yeah. Please hear me cry out, please hear me cry out. Down on my knees, yeah, please help me cry out. Down on my knees, yeah. How did I get here? I don't feel the same always. I'm going through some changes, I'm going through some change. How will I get there to a better place, please, yeah. I'm going through some changes, I'm going through some change.
Thank you, Georgie. Can we have his photo on the screen, please? Thank you. So moving on to the next one. So we have a bunch of variety of programs. So now we have Nihara of S7B Tech with a Marathi song.
Hi all, today I'll be playing you a Marathi song.
Thank you, Nihara. Okay, thank you, Nihara. So now we have the next song from Kesia Justin DeCruz of S3 BTech.
I'll find a way. I'll find a way out. But you never go away. So I guess I gotta stay now. Oh, I hope someday I'll make it out of here, even if it takes all night or a heartbreak. Yes, need a place to can't find one. Yeah, I wanna feel alive. Outside, I can't find one. Yeah, it's lovely. All alone, I'm in a glass now. I don't stop. Dive in the pieces, skin
Thank you, Kesia. Next, we have a melodious Malayalam song from Ashna of S3 BTech.
മഴക്കളി വെള്ളരിപ്രാവ് വാക്ക് കൊണ്ട് മുട്ടണ കേട്ട് മാതിക്കല വെള്ളരിപ്രാവ് വാക്ക് കൊണ്ട് മുട്ടണ കേട്ട് തുള്ളിയാമിനുള്ളില വന്ന നീയാ കടല് പ്രിയാനേ നീയാ കടല് മാതിക്കല വെള്ളരിപ്രാവ് വാക്ക് കൊണ്ട് മുട്ടണ കേട്ട് കാറ്റ് പോലെ വട്ടം വെച്ച് കണ്ണിടയിൽ മുത്തം വെച്ച് ശ്വാസമാകെ തീ നിറച്ച് നീ ഞാവൽ പഴക്കണ്ണി നറ്റുന്നേ മൈലാഞ്ചിക്കാട് അത്തറിന്റെ കുപ്പി തുറന്ന് മുല്ലവർക്കാട് വിക്രമോളണ തത്തകളുണ്ട് മുത്തുക്കളായണ ചൊല്ലണതിണ്ട് ഉത്തരമുണ്ട് ഒത്തിരിയുണ്ട് പ്രിയനേ പ്രിയത്തിട്ടുണ്ട് വാതുക്കൽ വെള്ളരിപ്രാവ് വാക്ക് കൊണ്ട് മുട്ടണ കേട്ട്
Thank you, Ashna. To make more colorful to our program, we have a mind-blowing dance performance from Kirti Vimal of second year MTech.
ജനന ജനന തനന തന tanana tom, janana janana tanana tanana tom, janana janana tanana tanana janana janana tanana tanana tom tom, janana janana tanana tanana tom tom, janana janana tanana tanana geeta dhuni ko takadhim natr kita tom naach rahe gori taaj dai tom tiragatum geeta dhuni ko takadhim natr kita tom naach rahe gori taaj dai tom tiragatum geeta dhuni ko takadhim तान गावे तक तल तै तै तान गावे तक तल तै तै तक तना धीम तकिड तक धीम धीम तकिड तक धीम धीम तकिड तक धीम हद तो मत गीत धुनी को तक पदुमनाभ तुम्हारी लीला क्या कहो मैं सावरो ताप संकट शरणायो सो हमारो तुम हरो ताप संकट शरणायो सो हमारो तुम हरो तजीम तजीम तिरना उदनी तानी तानी तजीम तजीम तिरना Dari tani 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 tirana tani tani galari galari tadagata tare tadagam tani tadagatam tani tini tagatana alari tom 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 tagatana tani alari geeta dhuni ko takadhim natr kita tom naach rahe gori tani dai dai tom tiragatum geeta dhuni ko takadhim natr kita tom naach rahe gori tani dai dai tom tiragatum tani dai dai tom tiragatum tani dai dai tom tiragatum geeta dhuni ko takadhim niku takadhim kadhim.
Thank you, Kirti. Now we have a song from Ken Prince of S7 BTech.
I'm Ken Prince, semester 7 student at Civil Department. When I look into your eyes, it's like watching the night sky. Oh, beautiful sunrise. There's so much they hold. Just like the morning star, see that you come so far. Be right where you are. How old is your soul? I won't give up. Oh no, even if the sky get rough, giving you all my love, still looking on, still looking on. Imagine there's no heaven. It's easy if you try. No hell below us, above us only sky. Imagine all the people living from today. You may say I'm a dreamer, but I'm not the only one.
hope someday you will join her, and the world will be as one.
Thank you, Ken. Now we have Durga from S7 BTech with a melodious song.
Anupami takamalavase Devi Anupami takamalavase Charu hasida kridagundani rase Devi munivaredita vimala charite mohaniya gunaugavari te janani mamava me Suruchira nayana jidainai parama karuna rasa shishira veni Devi sharanagata jana bharanani muni paramamrita sumadurava shini janani mamavame Anupami takamalavase Devi Anupami takamalavase Devi Anupami Anupami takamalavase Devi Anupami Sanidama Anupami Garigama Padani Sapa Sanidama Anupami Padani Sarima Padani Sarigama Pama Anupami Sanidama Anupami Dani Sani Sanidama Anupami Nida pa 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 da pa ma pa da pa 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 ma va da pa da ma 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 ni da pa ma va da pa ma va da pa ma ma pa 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 ma va da pa ma ga re sa re ga ma ga re sa re ga ma pa da pa ma ga re sa ma ga re ga pa ma ga ma da pa ma ma ni da pa ma ga ma ga pa ma ma da pa ni da pa da ma pa da ni sa ma da ni sa ni da pa ma pa da ni sa re ga ma re ga sa re ni da pa ma pa da ni ga re sa ni da ri sa ni ni da ri sa ni da pa sa ni da pa sa ni da pa ma Anupami takamalavase Devi.
Thank you, Durga. Now we have Jayakrishna Jayapal of S7 BTech with a melodious song.
हंसता रहता हूँ तुझसे मिलकर क्यों आजकल बदले बदले हैं मेरे तेवर क्यों आजकल, आंखें मेरी हर जगह ढूंढे तुझे बेवजह, ये मैं हूँ या कोई और है मेरी तरह, कैसे हुआ कैसे हुआ तू इतना जरूरी, कैसे हुआ कैसे हुआ कैसे हुआ तू इतना जरूरी, कैसे हुआ.
Thank you, Jay Krishna. Now we have an amazing dance performance from Suvarna of S7B Tech.
जल प्रवाह पावित स्थले कलेवलं व्यलंबितां भुजंग तुंग मालिकां धमड्डमड्डमड्डमन्निनाद वड्डमर्वयं चकार चंड तांडवं तनोतु न शिव शिवं 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 जटाकटाह संभ्रम भ्रम निलिम्ब निर्झरी विलोल वीचि वल्लरी विराजमान मोधरी धगत् धगत् ज्वलल्ललाट पट्ट पावके किशोर चंद्रशेखरे रति प्रतिक्षणम्.
Thank you, Suvarna. Now we have another amazing song from Lakshmi of S7B Tech.
ഹൃദയത്തിൻ ചന്ദനവാതിൽ നിനക്കായി മാത്രം തുറക്കാം ഞാൻ, നിനക്കായി മാത്രം തുറക്കാം ഞാൻ. നിന്മിഴിയാകും മധുപാത്രത്തിലെ നിന്മിഴിയാകും മധുപാത്രത്തിലെ മാസ്മരമധുരം നുകരാം ഞാൻ, മാസ്മരമധുരം നുകരാം ഞാൻ. എന്റെ വന്നീല നിന്നോടൊന്നും ചൊല്ലില, അനുരാഗം മീട്ടും ഗന്ധർവൻ നീ സ്വപ്നം കാണും ആകാശത്തോപ്പിൻ കിന്നരൻ, ആകാശത്തോപ്പിൻ കിന്നരൻ.
Thank you, Lakshmi. Now we have Marina from S7B Tech for another song.
വിരനിലാവിൻ സാഗരമായി പുഴകളിലേതോ ദാഹമായി, വിരനിലാവിൻ സാഗരമായി പുഴകളിലേതോ ദാഹമായി, കാറ്റിലുറങ്ങും തേങ്ങലായി പാട്ടിനിണങ്ങും രാഗമായി വരൂ വരൂ വരതേ, തരുമോ തിരുമധുരം. മയിലായോ മയിലായി പറന്നുവ മഴവില്ല് തോൽക്കുമെന്നഴകി, കനിവായി പൊഴിഞ്ഞു താ മണിപ്പീലിയൊന്നു നീ അരികെ ഏഴെല്ലാം കാവുകൾ താണ്ടി എൻ്റെ ഉള്ളിൽ നീ കൂടണയും എൻ മാറിൽ ചേർന്ന് മയങ്ങാൻ ഏഴുവർണ്ണവും നീ അണിയൂ നീലരാവുകളും ഈ കുളിരും പകരം ഞാൻ നൽകാം ആരും അറിയാതൊരു നാൾ ഹൃദയം നീ കവരൂ മയിലായോ മയിലായി പറന്നവ മഴവില്ലത്തോ.
Thank you, Marina. So coming on to the last program of the day, now we have group song from MTech batch, both first years and second years. We have Mirya, Mekha, Sri Lakshmi, Hamna and Manesh. Thank you, dears. So by this, we come to the end of our cultural program, Contact 2020. We are extremely sorry for our flaws. We'll upload the cultural program in our official YouTube channel. The link will be provided in the WhatsApp group. Thank you everyone for your valuable support and encouragement throughout this program. So tomorrow we have the TSR lecture at 5 p.m. by Professor S.R. Gandhi, Director SVNIT Surat, on underground excavation and anchoring, followed by the valedictory function, so requesting all your participation. May you all have a wonderful evening ahead. This is Hemna signing off. Thank you.
Requesting any of the external participants to have a comment on the cultural contact so that it will be an encouragement to the students. Any word from the external participants, please. Amit sir, then Singh sir is there, Unikishan sir is there. Any one of you, please. They put a lot of effort from their homes ahead of their academics tight schedules and done for us. Anyone of?
It was very good, very, very well. I think a lot of variety was there in the program. Very nice. Ken, Jayakrishna, Jayapal, all these people had these hidden talents with them. I think other students also. So I appreciate that. Very good. Nice.
Unikishan sir, are you there? Unikishan sir. I hope Unikishan sir was there. Was having a comment in the chat box. I saw him. I don't know whether he is there. There is there. Amit sir from China, please can you have a word?
Hello, everyone.
Amit sir, can you have a word on the feedback about the cultural?
Yeah. Hello, everyone. First of all, I want to extend my thanks and appreciation to the organizer of such a unique program. It is very much educative and informative. All of the lectures I've been participating and I highly appreciate. I highly want to say thank you for this cultural exchange program. I was able to listen to some very nice and beautiful Indian songs. So I'm glad, and I hope that in the future, you people can continue to organize some programs so that we can be able to form part and have some learning information from such unique professors and experienced engineers. Thanks.
Thank you, Amit sir. Thank you. So many more external participants were there. Can anyone more can add to a word to the effort made by the students for their culturals? Can I have anyone to add on to that? Joyce teacher, are you there? Teacher was there. Joyce teacher. Unikishan sir also left, I think. Unikishan sir is there? Sir? I think it's no one out here. So thank you, my dear students, for taking.
Teacher, if I may comment,
Yes,
is Kannan
yes,
here?
yes, you can come, Kannan.
Unikishan sir had another appointment, so he left. So he was just telling me via text and WhatsApp that he really enjoyed the program. Particularly, he could really feel that bhavam in that Bhairavi that Ms. Durga was singing. That was what he's an ardent fan of classical music. So coming from him, that is really great words of appreciation. And he was also enjoying all the other programs, also all the other singing and the dancing, and also he was saying that with the constraints we were able to arrange this. That was his comment.
Yes. Really, thank you, Unikishan sir, on the behalf of Kannan also for just conveying his message. Thank you, Kannan. And thank you all, and all my dear students who took great effort in this schedule of last minute ending up of semester exams and all that. Even then, they took a lot of pain from their homes. Due to COVID-19, we are restricted by so many things, but still, we tried to make this possible. That was our intention. So, by God's grace, today we blessed with even from the heavy rainfall and all that things. So thank you all participants for being with us for the long time from 3 o'clock till now. Thank you all. Again, we'll see you together tomorrow at 5 o'clock for the ending up program tomorrow with the TSR lecture and the closing panel. Yes, Amit sir, anything to add?
Thank you. Bye.
Thank you, Amit sir. Bye. Thank you from China. The comment from China is an encouraging word to our students. Thank you, Amit sir. Thank you all, and we'll see you tomorrow. Till then, take care and be safe. Thank you.